Hey guys.
Hello.
Hello, everyone.
Hello.
We're back at it. We took a day off on Friday, had other meetings going on, so we skipped a day, but we are back in the seats on Monday now, January 1st. So Happy New Year to the probably 2 people who are watching.
Yeah. Happy New Year.
Happy New Year.
2022.
Happy New Year.
Maybe.
COVID year 3.
But maybe for the future one person who will be additionally watching this video. But anyway, we're gonna cover answers for
14 and 15.
Okay, cool. So let's get right down into it.
Let's review the questions.
So let me share my screen. So 14, extended polymerization. I'm gonna take this one, Alexis, and see if you did it recently.
Just summary.
All right.
Yeah, just summary. You don't have to actually read it.
Okay, so what we needed to do is actually, if we look at the example, we needed to take this line, which is the polymerization code. And then what we needed to do is take, let's say, the first 2, check if they match with one of the left example under, and then if so, we needed to insert the character which is on the right in between those 2 values. So let's say NN, then it's C. So we needed for the next step to insert the C in between the NN, and then after that move on NC and then CB. That's what we needed to do.
Okay.
And then we needed to do a 10 step.
Yeah.
And then it was the final answer was a little bit more confusing, right?
Yeah.
We had to figure out the letter that occurred the most times. What was it? Yeah, we had to find the letter that occurred the most amount of times and subtract the number or the letter that occurred the least amount of times.
No.
The top end.
So in the example, they had, I think it was B occurred the most at 1,749 occurrences, and H occurred the least at 161 occurrences. So their final answer was 1,749 minus 161 to get 1,588. All right.
Well,
All right.
Let's
Okay.
jump into it. Alexi, do you want to share first?
Yeah, I managed then to do the first part of this one.
Welcome back.
Turn of the king.
I'm gonna find this one and zoom is big enough.
yeah, I think so.
Plenty.
Okay, so at first I just import the sample, which is here on the right side. You can see it's the same. Then he returns this one. So at the first item of my array, it's the code, polymerization code.
The template.
The template, the polymer template. And then just empty space, and then after that the code. So what I'm trying to do is I'm just saving this one into one variable and just get rid of this array. So then there would be an empty space plus this. So I'm removing the empty space. And then after that, what I've done is I created an object which the key is the left part and the value is the right part of the sample. So the key value would be CH and the key would be CH, pardon, and the value B. So for each of them. So then, okay. And then after that, I created an array, for loop, pardon, for loop. We needed to do 10 steps. So that's a looping 10 times. And then I'm gonna loop one more time inside, and which I'm looping through, it's to the polymer template. So if we remember, the polymer template is actually the code we needed to. So for each letter, I'm gonna loop through. Okay, -1. And then what I'm doing, what we search, the search is the way I thought it was to, I just keep going back and forth. The search is to get these 2 values. So the first one we take the 0 and 1, then the next steps would be to take 1 and 2, and then on and on. Okay. Until here. I just save it. So if the search would be the NN, I just save it here. NN, NC, CB, every time we loop. And then I just check if the search is matching one of my pairs, if I have it actually in my object. If so, I'm just taking the value of this pair. So if I go back here, if we have, for example, CH, the value is B, I save it into this variable to insert. If it's the first time we are passing to the polymer template, actually returning the first value of the polymer template. Otherwise, it's just an empty. We don't need to add it. To add it where? To the new polymer template. I just created actually a different polymer template, which every time I loop through here, I'm just saving it here. And then at the end, I just replace the old polymer template by the new one. So then it does that 10 times. Then when we are finished, I just check the unique characters. So what do we have inside, for example, C, B, or H, or whatever. So I save them. I also do, again, I create one object, which the count char would be the same, would be, for example, B, and how many times it happened, how many B, for example, we have, or how many H do we have. And then at the end, I just, okay, yeah, and this one at the end, I just found the minimum and the maximum of the object I just created, this one. And I just divide the max by the mean, that's it. And the value, the result for me was 1,588. Was it clear?
Yeah. I think your line 53 is interesting. So you take polymer template was is that an array when it first starts?
50, this one?
53?
Sure, this one?
Yeah.
This one, yes.
What was polymer template?
Polymer template, you know, is the code is this.
Oh, okay, so it's a string.
Yeah. 53.
Okay,
Yeah.
so you take a string,
Yeah.
turn it into a set, gets rid of duplicates.
Here I actually, every time I insert,
Mhm.
and just so I save it in this variable.
Right.
And then at the end, I just replace the polymer template, the old one by the new one.
Right.
And then at the end, I just get rid of, I don't get rid of actually, I just save in the unique char only an array of the unique, like let's console this one.
Yeah.
Char.
There's a lot going on there, is my point. I mean, you got a string that's getting turned into a set, which gets rid of duplicates, then gets turned into an array.
Yeah.
Oh, here, that one?
Yeah.
Yeah, okay.
I actually had that exact same line in my code.
Yeah.
It's a useful one.
Yeah.
It's a nice quick way to get rid of duplicates.
Actually, I searched for duplicate, and the
mine's
first
low.
thing I found it was this line of code, and I was like, that's
Oh.
exactly what I want.
Actually, mine's
I
even
couldn't
more
remember
complex.
I thought it was data set instead of just set. So that's why I was just trying to type data sets, like, yeah, what's going on? So I thought, get rid of duplicate in GS, and then that was the first line I found.
That's the way to go.
Yeah, perfect. So yeah, you return an array of the unique char we need to.
Right.
And then here again, just look through to create an object. That's it.
Cool. And you also have your loop is -1, right?
Yes.
So that you don't get
The last one, yeah.
the last one with no pair afterwards.
Exactly.
The last one's not going to split.
Yeah.
Right. Cool. Looks good.
Thank you. Stop sharing.
Maybe.
Do you have any question, Farouk, or no?
No.
Do you want to take the next one, Scott, since we're on the
Yeah,
JS side?
I can go. Mine's quite similar to Alexi's. Let me share my screen. All right, can you all see me?
Yeah.
All right, so here we go. This is actually my one without comments. I decided to copy and paste this into a separate file to add my comments just to keep this one clean. So here's my entire code. It's not that many lines, only 42 with some spaces and a few comments at the top. So let's see my commented one that's easier for me to describe.
Yeah.
So like Alexi, of course, I had to import my file. I ended up doing the same thing. I named mine polymer. So my polymer is going to be the first line from my file. So here's what my final input looked like. So my polymer is just going to be the top line here, and that's what I'm going to be adding to. I'm going to be editing that as we go. And yeah, so the rest of, and just like Alexi, I had an empty space that I had to get rid of too. So then the rest, I decided to create an array of my rules. So I have a rules array that looks like this. So it just has all of the properties. So the left side and the right side, each in their own subarray. And then I decided that I'd rather work with an object. So I created a rules object from there. So it's object from entries. I was able to convert all of this to an object easily. So now my rules looks like this.
So
Where the left
addressable.
side is the key and the right side is the value.
So that easily searchable and addressable.
Yeah.
structure.
Just the line 25 actually does create the entire object.
Yeah, if you have an array that's like this, where you
Okay,
only have
there's two values.
subarrays with two elements, then it'll create the left one will be the key and the right one is the value.
I didn't see it was only two values. I thought it was next to
Four.
each other. So I
Yeah.
was like, hey,
Formatting.
Yeah, the formatting here, these should all be on new lines, but
No,
just
we
to
don't.
make it display better. So yeah, now that I have everything set up, I can do pretty much just like Alexi did. So I created a constant variable here, or a global variable for my steps, because I wanted to be able to adjust this easily. So yeah, right now we're going to start with 10 steps for part 1. So we're going to loop through 10 times. And for every time that we loop, I'm also going to loop again. So we're going to loop 10 times, and now I'm going to loop through my polymer. So just as Alexi did, I'm looping through every element in my polymer. Although for some reason, I'm not stopping at the second to last element. I'm going all the way to the end.
I think it's your if statement on 43.
Yeah, let's see what I'm doing here. So for my if statement here, I'm checking if I have this polymer. So this will be the current element and the next element. So for example, at the top, the very first time that we go, I'll be looking at the n, the current element, and the next element, which will be another n, if we go up here. So I'm looking at the current one and the next one. And if we put those together into a string and look in my rules, well, if we look through here in my rules, we can see NN is going to be with C. So that's going to be in here though, somewhere there will be NN. Down here, there will be a property NN goes to C. And so now that I find this, I'm going to insert that element in my polymer. So now my polymer is going to get a little bit bigger. And now, because my polymer is a little bit bigger, what am I doing here? Okay, this is all just for my insertion. Because I'm working with a string, I can't just easily add it in place at that index. I have to do some slicing. So I'm going to slice, I'm going to get the, let's see. Yeah, so I'm slicing from the beginning of my string until the first element that I have. So this one, I'm going to take that and everything before it. I'm going to add in my new element, and then I'm going to concatenate everything after it. So now my string has just been expanded with that one thing in the middle of those two elements I'm looking at. And now because my string has increased in length, I don't want to recheck the same thing again. If I keep my I as the same index or increment my I one time, then I'm going to recheck the element that I just inserted. I don't want to do that, so I'm going to increment my I again right here after inserting.
Yeah, it's the -1 is still not addressed.
But I don't need that -1, I guess, because my if statement, I guess, will fail if there's no polymer of I+1. I'm guessing that's why.
It should fail. because it should evaluate or try to evaluate polymer I+1 before it even creates the string as part of the string, unless there's something interesting with the string interpolation that failures are disregarded,
Yeah,
like undefined or disregarded. Huh, interesting.
seems like JavaScript takes care of it for me. Because yeah, I'm not getting errors on this one.
The black box JavaScript.
It's nice.
It's nice until it's not.
That's true. That's true.
Oh, that one bug that he's not telling you anything about. But yeah, okay. So you got it to work.
So yeah, so now my polymer is complete. So my polymer variable that I have up here is going to have my entire polymer after 10 steps. So all I got to do now is count the letter that appears the most amount of times and subtract the letter that appears the least amount of times. So very similar to Alexi, I'm creating a set, although for some reason I'm using my rules object in order to get my unique letters.
Yeah, assuming all the letters appear in the rules,
Yeah, which they have to, based on the rules.
unless it only appears in the beginning letters. It does work for us here though.
Yeah,
Like if the very first letter was like a Q and it
it
doesn't.
never appeared again.
Yeah,
But luckily that never happened.
right.
Every letter was used.
Cool.
So yeah, then I just got to loop through there. I'm storing my maximum and my minimum, and I'm overwriting these when I find a new max and a new min. And then I'm just subtracting those and printing out my answer.
Using regex.
It's a reject master.
Yeah, I really like that regex.
It's
Man.
easy.
Cool.
Yeah.
All right. Who wants to go next?
Okay, I'll go. Is Python. All right.
Ours were too similar.
Yeah.
Let me see.
Many people must have the same approach.
Yeah.
on this.
Yeah.
And then
It's
they
just-
realize on the second one, that's not possible.
Yeah.
I think that's what he knows. Like the guy who creates these puzzles knows. Like, he's like, everyone's gonna go for this approach first.
Well, it doesn't help that it's the instructions.
Yeah.
If you just follow instructions, that's what you're gonna code.
Exactly,
Yeah.
because clearly that's what I did. I really did procedure. It's like I just read, okay, do this, okay, do that.
Yeah.
Oh, it works. Like literally.
I like doing it that way the first time every time because I feel like I'm following the instructions. I'm doing what I'm supposed to do to help the submarine.
I
And
don't
the
like
samples
unexpected.
work.
You don't want to take these shortcuts that you have to for part.
Right.
Because also that's purely assuming that it's gonna be like that the second part, but you're not sure also.
Yeah.
So
Okay, so first I'm passing my input as an array of strings, my entire sample input or this one here, I'm passing all of them as an array. And then I'm taking my template, extracting my template from this array, the first element of the first one. Then I'm creating a dictionary to keep my instructions as I keep set. My pair will be the key and letter will be the value. So I'm looping through the rest of my array and inserting the according values into my dictionary. So now I have my dictionary and I have my template. I'm copying my template into this temporary array because, as Scott mentioned earlier, you cannot modify the strings in place. So I'm using the temporary string value instead of the original string. So I have my for loop and I am assigning my temporary array into another array variable. And I'm looping through every character in my temporary array. And I'm not modifying this one. Pay attention, because if I do not assign it to a variable string, I will be modifying my temp array, and as I modify it, this length will also change. So it will be it will not be static. So I need a variable that I can modify, and temp, which I can keep the length for. As I loop through my temp, if I have, yeah, I think slice concatenating my array, I'm taking the first half and I'm getting the pair value from my dictionary, and the second half from my variable string. So I think this is similar what Scott had earlier. The first half of my string,
Alexis.
my
I was actually
pair
modifying my
value.
original string.
Yeah, it's more like me. Yeah.
But you are not modifying. You are assigning it to itself, right?
Yeah,
So,
without using a temporary. Or without using a temp string.
but it's also same thing. Like even so, I'm using a temp string. I'm assigning to itself after modifying. So yeah, this is how I am modifying my string, and at the end, I'm assigning it back to my temp string. And here, okay. So every time as my string changes, I am appending my old string into my joint pairs array, and doing the same thing for my new array, for my new variable string in the loop. So once the loop is over, I think I probably do not need to store those values, but I'm getting the last value from my array and creating another dictionary for the counts. I am looping through my last string, last output, and incrementing the letter in my dictionary. So basically frequency counting, getting the values, sorting them, and subtracting the minimum one from the maximum one. And that's the answer.
Okay. Looks like you didn't need the
Yeah, this one.
You could have used template as well.
Oh yeah, that one also seems unnecessary.
Because you never use template again, so. But anyway. Also,
And I also
naming
don't
variable
think this-
variable.
I like that.
Variable,
What was that?
You named variable variable.
Yeah, because it's varying here. We are changing it.
Descriptive. What is it? It's a variable.
It's a variable. I don't have any other variables. This is the variable.
Yeah, so yeah, that's my approach.
Cool. Yeah, streamline.
The first half, it was straightforward, but let's see part 2.
Cool.
Okay, Alex.
Now I'll show you the Rust version of what you guys have done.
Yeah. Same thing.
Yeah, pretty much. We're on day 14.
Yes.
Okay. So for me on 14, turn everything into a vector of no, not numbers, just lines. So I split everything by the arrows, right? And so basically creating what you guys had created. The only difference is I just look for lines that have the arrows. If the lines didn't have the arrows and it wasn't blank, then it's the first line.
Okay.
So that's the only subtle difference between us trying to create our initial data structures.
I feel like sometimes the way we import the first thing really gonna guide us the way we are gonna code after. You know, like the word.
Well, or the reverse. Like I'll have an approach in mind, and then I'll make sure all my data is formatted to fit my approach. Right?
That's more how I do it.
I think sometimes I get tricked I tried something, okay, I got the data, but I feel like I don't have, I mean, I don't think I don't have that badly at first. I just have some data,
Right.
and I'm gonna try to do something with it.
Yeah.
And then that's, I think, yeah, that's wrong.
Well, yeah, there is a bit of sunk cost in it, right? Because you spent all this time getting it in this format and you're like, okay, I should be able to use it this way.
Yeah.
But you have to be flexible enough to say, all right, scrap it. Let's
Yeah.
do
Let's
it another
redo
way.
it.
Yeah, there will be a couple other puzzles in the line where I've had to take my original one and then even go further and massage it even more to get it ready for another one. You'll actually see that in 15. But yeah, so I wouldn't say it's wrong because you have to get it some way, but you should be flexible enough to go back and say, okay,
Yeah.
I'm going to change it when I need to change it. So I have for mine, loops within loops, except I have my for loop is in 64, which calls a function, which is the for loop in 45. So it's, but it's pretty much the same, from 1 to 10.
Just isolated.
Yeah, I just isolated it as a driver thinking, oh, maybe part 2 I'll have to do it like 255 times or something like that.
Almost right.
But the cycle itself, I try to isolate. It was one cycle, what's going to happen. And then in one cycle, essentially, we pull out one letter, a pair of letters, right? This one I don't use a window function. The second one I use a window function, something I discovered along looking at the documentation here. But anyways, so you take the 2 letters out, split them up, and then stick the intervening letter in between. Yeah, that's
Not much else to it, really.
except for I'm looking through mine, and it looks like I only push the first 2 letters. I don't push the 3rd letter in because the 3rd letter is going to be used again anyways in the next round. So it saved myself a little bit, I guess. So you see me pushing only the first letter and then the new letter, and then probably reusing the last letter. Yeah. So, but working with arrays, and at the end of it, just going through the arrays and counting them. Yeah, +1 if I find something, and if not, then it's a self-replicating, it's a hash map. So it starts out with nothing, and then if it doesn't find anything, then it inserts it and puts a 1 in its place. If it does find it, it's +1. So it just builds the counts as it needs to as it goes along. And then, yeah, take all the scores, sort them, just like myself Farouk do, and then just take the last one and the first one. Last one minus the first one.
All right. And I guess we can jump straight into part 2 because there's not real much explanation needed. Part 2 was the exact same thing, but for 40 cycles instead of 10.
There you go.
What does that clone to, Alex? You have on the line 79, counts, values.
Yeah. So,
Is it like a deep copy, deep cloning?
yeah, it is. Well, it can be. So there's 2. I don't know how deep you want to go into Rust, but the whole thing with the borrow checking in Rust, because of references and pointers and whether or not you have a real copy or you have what's called a borrowed copy instead of an actual pointer or reference in C and C++. There's a possibility that what you have might not be quote unquote yours. And what that means is when that scope is destructed, wherever you're using your variables or your values, when that scope exits, everything that's considered to be owned by that scope is destructed, and that's part of how Rust does its garbage collection. And so you have to take into account lifetimes where some things will be alive for a certain period and they won't be alive for another period. I had a problem with this line in the sense that I think there was a chance that the values or the counts would disappear before I can get into the collect. It was either that or something else. I don't know. It got to the point where when the compiler would start complaining about life cycles or start complaining about oh, this is a reference to a reference instead of this, maybe you should do that. And I was like, all right, I'm just going to do that. And it suggests you to do things. And one way to kind of cheat around it is to just start cloning everything. And it's completely memory intensive and bad behavior, but it gets me to my destination. So I just say, forget it. I'll think about the most efficient way to use my objects in my memory later And I just want to get this thing done
Solve
now.
the puzzle.
Let's solve the puzzle, right?
I thought, yeah, it's similar to deep cloning in JavaScript or deep copy in Python, where you copy the value by value. You copy the array by value instead of by reference.
Yeah, you have to be careful though. By default, yes, that's true. But you can create customized clone functions. And so the clone may not go as deep as you think, depending on the way that you use it and the classes or the structs or wherever you end up using it. But yes, by default, it is a deeper or a deep copy, especially if you use primitives along the entire hierarchy of your object or your data type. But yeah,
Thank you for the clarification.
That's the clearest I can, with my limited knowledge of Rust, the clearest I can explain it.
Thank you.
Yeah, thank you for this clarification.
But
Yeah.
there's another version. So there's, okay, so we're gonna go deeper down this rabbit hole. There's a copy, there's a clone, and then there's a two owned. And they all do something similar, but subtly different depending on the context. So you can, for the most part, use any one of those and it'll work. But the ramifications of those won't be evident until deeper down in your code when stuff starts going a little bit sideways. So
you got to know all three.
So you have to know kind of what you're doing when you start getting more complicated and long with all three of them. And but for the most part, as a beginner, as long as you stick with like one of them and you keep going, chances are you'll be okay. The most common one I think is going to be to owned, because that's somewhat the more cheaper one. And then clone or to cloned, if you want to put it into a pipeline like I do, is the next one. And then copy is the one that's going to be kind of you have to know what you're going to be using it for to make it really relevant. Or if you're creating a custom struct, you can just declare it as something that could be used with a default copy, and now you can pass it as a variable, as a value between functions and function calls. I don't know. There's a lot of fundamental, maybe not even fundamental, but like really like pipe working that you guys don't have as much access to if you do interpreted languages. And it's all starting to, like, all my C days are starting to come back to me now, and it's not necessarily pleasant. I don't fight as much with logic anymore with Rust. I'm fighting with the borrow checker, I'm fighting with the type checker, and it's not like I don't know how to solve the problem. It's just the stupid syntax is killing me. But I don't know, eventually I'm sure I'll get to a point, if I stuck with it long enough, and be like, oh yeah, this is a way to solve it, but I'm not there yet. And it's kind of maddening in some ways.
That's how I felt in Java when I was working with Spring. Yeah, I felt like it. Like I was trying to solve some code wars problems, and it got like crazy. Yeah, I was not worrying that much about the logic. It was mostly about how to modify the data structure so that I can get what I want.
You're fighting with the language more than the actual question.
Yeah, when I did code wars with Java, it was like that.
Cool.
Let's get on to part 2 then.
All right, so part 2, while we still got Rust up, let's see, that was day 14.
Yes.
So day 14, so part 2, resulting polymer isn't nearly strong enough, blah, blah, blah. Now we have to do it 40 steps.
Right.
So, and the same thing, most quantity subtracted by the least quantity. Oof. So 40 steps. And I think, because I had everything already sent out with the loop, I was like, oh yeah, I'll just increment my 10 to 40, right?
Sure.
Yeah, sure.
Explosions.
Like everybody,
What's the worst I can
I
have?
mean, that's the first thing you think
I
of.
think I tried that too. Like I knew it was not going to work.
Yeah, me
It's
too.
like, well, let's just see.
And so I have here's my graveyard of many different kind of attempts.
I think, yeah, you do know that's not gonna work, but deep down it's like, maybe
Yeah.
it's gonna work.
Maybe.
You can see from the
Hopefully.
example, like the answer for the example problem was 1,588 for part 1. The example for part 2 was, let me count all the digits here. There's million, billion. I think the answer for part 2 is 2,188,189,693,529. So yeah, we're already into the trillions.
Well,
So-
it almost doubles. It's almost a power 2 of every one, right? Because of every one, it's
Yeah.
-1, and it just keeps growing in that rate. It's almost a doubling rate.
And their polymer started with 4.
Yeah.
Ours started with a lot more than 4.
Right.
So we know it's going to
For
be a
me-
gigantic number, probably
After
hundreds of trillions. If not-
after 17 or 16, mine already stopped like really slowly. After 17, it was taking quite a long time for every step.
Right. Well, mine was a little bit more insidious. Mine didn't really slow down until the 20s. And so it kept on thinking, making me think, oh, maybe if I could optimize a little bit more, optimize a little bit more, and then it goes to 25, optimize a little bit more, it goes to 28, and optimize a little bit more, it goes to 29. And it's like, where do I go from here? Do I keep optimizing? Or do I scrap and start over?
Yeah, or what I like to do is I just let it run like in the background while I start working on a better answer. Like I'll just,
that's
maybe he'll get lucky and it'll pop out an answer before I'm finished optimizing, or probably the other way around.
Yeah, never know. And so in my graveyard, you can see me trying to get, some patterns, counting only certain letters. I think at some point I'd try to see if there was like a frequency, a repeating frequency, where there was like a percentage amount in terms of like how many times. I think that's was done in one of these. I was trying to get like about a percentage amount, how much, what's a percentage chance that one of these will pop up, and see if that's consistent across iterations. It wasn't. It started to
should be.
It started to converge, but it was never stable. And so, and then I did a couple other things. I started thinking about lookups, and I think that's when I started getting back on the right track. This is more about frequencies, a table of frequencies. So yeah, okay. So now I'm looking at the problem more with what I have instead of trying to build the entire string. But anyways, so the approach that I ended up with, at least let's try to go with that. So the approach I ended up with essentially is, okay, so I'm going to be building out the string, but I'm going to be only trying to make it so that I just create a table of totals and I just look at small bits as I go along. Because I know these small bits are always going to be growing, but these bits, once I count them, I don't really need them anymore, right? So I can do, it's almost a frequency counting on a lookup table.
For pairs.
For pairs, yeah, exactly, for pairs. And so the first one, I create a counter for each letter. Okay, that's for later on for counting the characters themselves, but that's the actual like thing that we want, right? Is how many characters of each character that we have. And so I create a data structure to count the characters. Okay, again, so not so much focused on creating this huge string and then counting them. I'm going to count as I go. So that's one optimization. And then I have the frequency counting for the table of pairs, and I need this because for every cycle I need to know which letters are going to split. Right. And so in order to know which letters are going to split, I need to track the actual pairs of letters. And so this is going to be tracking my pairs.
That's the key part right there.
Yeah. And then I just start with the first two. So I have this interesting window function that I've seen in other languages, but I didn't realize that it was in Rust. And I was like, oh, I want to use it in this one. So I was like, oh, that's a great opportunity. And so it just basically is it's like a sliding window along your array with only the amounts that you wanted. So it was only 2, so it's kind of stupid. If it was like 5, it'd be like, oh, this is awesome. 2, which is like x and x plus 1. What's the big deal? But anyways, there it is. So, and then so for each pair of letters from the beginning, I'm going to get, for my input, for example, it's going to end up being looking like. There's going to be a PK, a KH, an HO, an OV, a VV, so every pair of letters.
So you're just incrementing those in your pair counter.
Yeah, so my pair counters, I know I have one pair of PK, one pair of KH, one pair of HO, one pair of so on, and those need to be split, right? So I know there's one of each so far. Actually, there might be multiples, like VVs twice, right? So I got 2 VVs in here. And I'm sure if you stared at it long enough, you can find other pairs as well. But that's what it's counting. There's a data structure that just counts the possible pairs and how many there are of each of those possible pairs so far, right? Okay, and then we have our cycle itself. And the cycle itself, so we're going to take each of the pairs, and I'm just going to create a new copy because it's going to be something I do in a loop. And so I want to keep those as I go through the loop a little bit separate, especially I think because mine is going through a fold as a loop mechanism. Anyways, but yeah, so I get the pair, I pull out the pair 1 and 2. the new character, which I get from the pairs table, right? This is, I created from the last exercise, which for every pair, what's the equivalent thing that's going to be stuck between them? And then that I end up with 2 pairs now, because if I start out with, for example, PK is going to split into 2 pairs, right? Depending on whatever letter is going to be in there. So if I do a control F on PK, it's already.
Yeah, I can't see it yet. It's further down.
There you are. So it's an S, right?
So now you're gonna have PS and SK.
Exactly. Yeah. So I'm going to have a PS and an SK, one of each,
Yeah.
right? And then I'm going to do that for the next pair, for the KH. KH, what is its pair? And then, break down that. And then basically I'm going to create a new array of pairs but with different counters.
You
Now,
gotta get rid of that initial pair now then, right? You gotta get rid
yeah,
of the
well, I just
PK.
I don't think I even use that
That counter.
yeah, that counter. I just create a new counter.
Okay.
But the other thing that is also optimizing is once you get numbers greater than 1, you don't have to redo it for those numbers. For example, if I find 2 HHs, right? I don't have to do it once, or 2 VVs, let's say in our case. I don't have to do it once here and then do it again once here, right? Because it's in my counter already as a 2 under the VV.
Yeah.
I just take my results for 2, let's say it's VO and OV, and I multiply by 2. So both of them, I already know it's going to be a 2. And it's going to help, dividends down the line when there's 20 of them. When I split the VV into VO and OV, whatever, I could just put 20 under them, or 21, or the case may be. And so so it saves me a lot of loops, right, in that way. And so that's the other huge performance
Huge.
benefit. Yeah. And so that in terms of the lookup and the counting of the pairs and the lookup of the counting of the pairs, that value, how many we've counted in the past, instead of having to recalculate, I can simply add those on to the next one. And so, yeah, and then after that, it's the same, just
Count the scores.
count the scores, which essentially, is counting the characters I counted along the way.
I like how short your final code ends up actually being.
Yeah,
It's
right.
not that many lines.
No, that's the approach, right?
Yeah.
That's what's highlighted in this one, is that once you find the approach that works, then, things start to fall into place and you realize, oh, that's a really elegant but good way of solving these kind of problems.
Yeah.
Especially when, like I said, I think we had this conversation during lunch, but a lot of these admin of code questions, when you start getting into giant numbers, frequency counting tends to be something that comes back in, right?
Yeah,
Farouk's favorite
many
thing,
times.
frequency counting. It'll save your butt if
Yeah.
you don't want to do large numbers of looping.
Yeah.
Is to just cache or save the results and try to process results rather than trying to process the problem set itself. So
I think for array related problems, frequency counter is a really commonly used approach.
yeah, you can see why. It's saves a lot of process cycles if I can take repeating loops, right? Repeating things that that would otherwise have to be done 20 times or 50 times. Just do it once and just increment it. Oh, multiply this by result by 20 and then go on to the next one.
Well done.
That was mine.
I feel like this is where it started to get hard. I feel like days before this, there were some things that were difficult, but I feel like 14B and like 15, where it actually started to bog down and questions started significantly longer
Sure.
than like day 10 and before. This is where I started to get like a day behind and then 2 days behind.
Well, I think, this year, I think it started with, was it day 6, the lanternfish? The ones that
Oh.
you do it on a schedule rather than, trying to figure out the life cycle of this fish that, sometimes it's 8 days and sometimes it's 6 days, depending on whether
The
juveniles or
very
adults.
first frequency counter one.
Yeah, exactly.
Yeah.
It actually started earlier than I thought. I didn't see problems like that until like day 15 like this, but it was interesting.
Should we see Farouk's?
Let's keep going.
Okay. I think what the approach you had, Alex, I thought about that approach too. So this is my part 1 approach, as you guys saw. And after changing it to 40 and seeing how big my string was getting, I also realized, yeah, it's not the way. And there should be a pattern in order to minimize the output and use less processing in every loop. There should be a pattern. So this is my change, my part 2. It did not really work. I could not get the answer by changing my part 1. So I took a different approach in here. Calculate, parsing, to parse my input. So this time I'm getting my input too, let's say sample input, and passing it to my parse string, where it will parse my string and give me the template and insertions, a little bit more optimized version. And after I get my template and insertions, I'm passing this into my calculate function. So in Python, I found out that there is a counter method which will create the dictionary by taking the argument. So if I pass my template string, it will create a dictionary with the count of each character. So I don't have to do the loop myself. Mm-hmm. And so I'm creating this counter first, and my pairs counter, which will be the count of the pairs in my string, as you explained earlier. So I also have the count, so CO, OP, and PB, and so on for every pair in my string. Yeah, so this is for the sample input. I have the count of every pair. And once I have the pair, I have the step counter, and basically it's a similar approach to what you had. So I am taking my pairs first, one and new character. So we will make a new pair themselves, and then new character and second pair, which will make the new pairs themselves. And I'm adding my previous count to the new dictionary count. So I'm also basically having the count of every pair as a string increment. Yeah, and after that I get my items, which is the count of the pairs from my value, from my dictionary, and subtract most frequent from the least frequent.
Okay, and you're actually deleting the original 89, right? So I see you're reusing that data structure.
Yeah.
Cool.
So modifying it.
Looks good, really similar to Alex.
Yeah. Any questions?
When you're using a 0, 1 before, that could have just been a 1, right?
Here?
No. This is from like, it's scrolling all the way back up to the top. So it's inconsequential. It's just something that for some reason I kept thinking about. No, scroll all the way to the top. All the way to the top. Let's see. That's line 10.
You mean like this?
Yeah, because you're only getting the first element, right? From 0 to 1, which is only 0.
Yeah.
I don't know. For some reason, I was like, what is that? Is there something special in there? But I don't think there was.
Let me check it. I actually did not understand also. I forgot why I had 0 and 1 there.
No.
So yeah, it's not giving it.
0 to 1. Is that inclusive? Because it's a.
So if you see my input, it's an array, right? Mm-hmm. So is it an array of arrays? No. So am I getting my input like this one?
So what happens if you just do input 0?
So I think it is inside. It's returning an array, right? If I put 0, what do I get here? String itself. So I can do it like this.
All right.
So I got confused when I sliced the array first and then gets the first element instead of just getting the first element. Yeah, thank you. And as I go on, I think Python, I'm starting to see these useful methods which Python have in JavaScript. I think do not have, like counters.
A lot of code.
It has, yeah, it has a counter. It has a default dictionary int. Methods, which is really useful when doing this kind of calculation. Saves a lot of lines of code, quite a bit of lines of code.
Nice job.
Okay.
My turn.
I think Python also has iter tools. It's also something pretty commonly used in there. Anyway.
Let's see JavaScript again. So my JavaScript was pretty much the same approach as Alex, but minus his smart thing where he kept track of the number of each characters. So I only kept track of the pairs, which added a little bit, which made me have to do a few more steps at the end in order to get the total count of each character. So here's my final code. And let me go to the one with comments and I'll go through it. So my initial part was a little bit different now. So I got my template, that's the first line of the input, and I got my rules array, same thing as before. I changed my rules array to a rules object so that I could have the key and the value for each one. And now for my actual polymer, I changed the way that I did it a little bit. So I ended up making my polymer just an object of pairs. So similar to the way that Alex and Farouk both did it, they kept an object or a map or a dictionary that saved each pair and the number of that many pairs that we have in our polymer. So, and yeah, after creating my polymer, all of my pairs initially were empty. I set them to 0. So I had to initialize it using my template. So I used my polymer template, added all of the ones that existed as a pair into my object. So for my sample input, my initial object now looks like this, where I have CH, I don't have any pairs. HH, no pairs. CB, I have one pair of CBs. I have one pair of NN and one pair of NC. So that was the initial object. I think it was NNCB was the first one. So now I'm gonna loop for 40 steps. So now what I'm doing here is I'm cloning my polymer. So I'm creating a new polymer because I want to do everything simultaneously. So I'm gonna update my real polymer after figuring out what all additions I need to make. So I'm creating a clone of my object here. And my favorite way in JavaScript to create a clone of an object is to do JSON parse and JSON stringify. So that way we can get a little bit of a deeper clone. It is a little bit error prone depending on what information you have inside, but for this case, it works fine. Alex is laughing. I'm sure he knows better ways to do it.
No, I've done the same thing. I've always thought, I was like, oh man, this is really hacky, but hey, it works.
It works. I feel like in JavaScript, there's no great way to do it without creating your own custom function that has to include all these special edge cases. Whereas if I don't have any special edge cases, this is just a quick way to do it.
Yeah.
Which is nice for puzzles.
It's good for puzzles. It's probably really high in IO and
Yeah.
or whatnot, because you're basically manipulating strings, right, behind the scenes.
Yeah.
But it works. There's no complaining about that. It works. I use it too.
Okay, it's good to know. All right, so now I'm gonna loop through every pair in my Polymer object. So I got a for loop here for pair in Polymer. And I'm going to check now. I'm going to check if I have more than 0 of that pair, that means I need to split that pair. So if I have any occurrences of that pair, for example, CN, I don't have any occurrences, so I'm going to skip that pair because I don't have to do anything with it. But for NC, for example, I have a pair of N and C, so I need to split it. So let's see what I need to do. I'm gonna, I think just like Alex and Farouk, I'm gonna create 2 new pairs. My new pair 1 is gonna be the first letter in there, so N plus my whatever new letter is gonna be added in the middle. And I'm gonna get that from my rules object. So, and pair 2 is gonna be whatever came from my rules object and the second letter in that pair. So now I have my 2 new pairs. And so I'm going to add them to my copy, my new Polymer. So I'm adding them in there. I'm increasing the value by the count of the original value. So however many of the original pair I had, I'm adding in that many of the new pair. For in this example, I had 1 NC. So I'm going to add in 1 of whatever my new value is, maybe NS, and 1 of SC. And now since I'm going to reuse that same object, I need to subtract the amount of the original pair. So I'm subtracting the original pair from my new Polymer object. And now I'm going to do my thing here. I'm going to copy my new Polymer into my original Polymer and restart my loop. So at the end, I'm going to end up with an object like this that is beautiful. It'll have the count of every single pair. Because I know every pair is going to split in the exact same way. So all I need to do is count the pairs. But now, because I did not have the foresight to count all of the characters as I was going, I have some more work to do. I mean, I could have just done this visually and look at the numbers and use a calculator to get the final answer, which probably would have saved some time. Because otherwise, I have to do like I did before. I have to get a list of all of the letters that appear here, because we have most of the alphabet, but not all of it. Then I'm going to create a totals object. So it's just going to be empty at the beginning. And I'm going to loop through my letters and add each of those. Let's see. Yeah, I'm going to add all of the letters into my totals object. So now I'm going to have every letter, A, B, C, D, initialized to 0. I'm going to count the number of letters. And now here's where it gets a little bit, oh, not quite yet. So now I'm going to go through my letters again, and I'm going to search. What am I doing here? I'm going to search through each pair in my Polymer object. And if the current letter is part of the pair, I'm going to add its count to my total. So if it exists in my Polymer, or in my Polymer pairs, I'm going to add it to my totals object. All right. But now we had some problems, because when I have a pair, for example, NC, that if it's in the middle of my Polymer, that N is going to be part of 2 pairs. It's going to be part of maybe SN and NC. So that pair, that N is going to be double counted. So I need to take care of these double counted numbers. And the only ones that will not be double counted are the very first element and the very last one. They will only be part of 1 pair. Everything in the middle is going to be double counted. So we need to handle that. So I have some little if statements here. So if I'm dealing with my very first object in my template, which will always stay the first object, the first letter in my template, the first and last ones will never change. Or if it's my last letter in my template, I'm not going to do anything right now. Otherwise, I have to add 1 to it and then divide it by 2 to get my final count. All right. So I want to pretty much divide by half every number that comes in, right? Because it's included in 2 pairs. Yeah. Now that I have that, I can finally get my minimum value and my maximum value and abstraction. So it was much easier to count the characters as you went, like you guys did. That was much smarter. Should have done that.
Did you have to use the spread operator for the min and max? Could you just not pass in the values themselves? 123.
Yeah,
The
let's see
spread.
what I had before there.
Oh, okay. Let's see. There, I don't. Maybe there was a reason why. I don't know if it like mutates the or changes the value or not.
Let's see, I'm sure I have a reason.
Uh,
I hope I have a reason. I don't know if I actually do. What?
Sometimes you just go into autopilot and just type in what you've seen or what you've done before. Oh, and I get not a number.
Yeah. So I do have a reason for it. What is my values?
Values should just be an array of all the values. Okay, so you got an array of values now. So math.min takes what as an argument?
It just takes individual values, not an array of values.
Oh, that's right, that's right.
Yeah, so,
So it's a list, yeah, it's a comma separated list
separated
of arguments, values, right?
Yeah.
That makes sense.
So just spreading it's a simple way to deal that.
Right.
But yeah, we all ended up pretty much with similar approaches. Some were more optimized than mine, but we all got there. Then
Yeah.
eventually the code runs super fast too. You can
Right.
see here, boom, it's less than a second.
Pretty amazing that, think about the fact that somewhere behind the scenes, the computer's just counting.
Yeah.
Yeah. And these numbers are huge too. Like, see,
Yeah.
this is just for the sample problem. I have this many pairs in the final object. Like,
Right.
that's huge. Look at these. Look at NB and BN. These are gigantic trillion numbers.
Granted, we saved the computer a little bit of grief because, once we get, a giant pool of numbers, going to the next cycle is just copying over those numbers and then adding new ones in, but it's still pretty darn big.
Yeah. Whew, this was a fun one.
Cool.
This is where it started to get.
Baruch.
Oh, we lost him, man. We didn't even notice. Wonder how long he's been gone.
Well, he's not completely gone. He's still hanging by a tether because he's still in the room.
Oh, Farouk, are you alive?
Somewhat.
You did, man.
Oh, now he's
Oh.
okay. So
That's your stage costume.
That's the inside. That's the thermal insulated inside. So it's flipped inside out right now.
you're wearing
You
aluminum
won't have a single
foil.
line.
That's my warm underclothes.
Yeah.
It's super warm. I can pretty much wear that alone, like out in the winter. That silvery lining stuff makes it super warm.
Radiant heat reflection.
Yeah, Columbia, baby.
Does it breathe?
Yeah, it's okay.
Welcome back, man.
Hey, we lost you.
Hey guys. Yeah, sorry.
I was talking so much I didn't even notice you were gone. I'm sorry.
Yeah, I was also talking like here rising problem 14, number 14.
Okay. Well, should we go on to 15 then?
Oh my gosh, we have another one.
Oh, yeah, it's been a while
I
already.
forgot that we we only covered one so far. Okay, so let's go to 15.
15 was another big boy.
Yeah.
I think it's this one.
Hard problems are like mean people who don't want to give you anything, you'd want the answer, but they don't want to give it to you.
Pain and sweat.
You gotta work.
Yeah.
All right, so day 15 was Titan.
Yeah.
Titan was basically you have this map of risk levels, and your job is to find the quote unquote cheapest way through the, I don't know what these are. What is the word?
We're in a cave, I
Oh,
think.
we're in a cave.
A cavern.
Yeah. And so we got to find the cheapest way to get through this cavern.
We don't want
And-
to anger all the children.
Yeah, I don't want to piss off all the Titans. And so with this map of risk levels, you got to find the lowest. And so of course the problem set or the the map they give you is much larger than this sample set, but
I think the sample one's 10 by 10. I think the full input was 100 by 100.
yeah, so an order of magnitude difference.
I feel like this is a really common question for like CS majors, probably like pathfinding, finding the
At some
most
point,
efficient path.
at some point, it's also quote unquote fun for the kids because it's like a game, right? It's relevant to everything you do because you can like now program your way through the game you're playing.
I feel like this is good for me though, because without not coming from a CS background, it's like my first time experiencing this kind of problem, which is very useful. It's been studied many times. There's pretty much set algorithms that people commonly use.
Yeah.
So it was good for me to be able to learn this. It was a good opportunity, I think.
Yeah. Something something definitely it's one of those things where the solution sets, because there are a few or very a handful of really common algorithms that once you learn them, it's it's something they can reuse pretty quickly.
Yeah.
Kind of like the idea of stacks versus queues, and once you get the idea, you can use them pretty quickly. Frequency counting is another one that we went through, but pathfinding is another one.
So I feel like, yeah, go on.
No, go ahead.
I feel like we covered these similar problems in my CS degree back in university by dynamic programming or whatever, but I surely did not listen to the lecture because it was not familiar to me.
CS majors study this, but most of them didn't actually learn it. So I'm really not at a disadvantage.
So I had to sweat for this one.
This was a tough one.
But now that you've sweated, now you won't forget.
Yeah, I hope so.
Okay, so who
It
wants to
seems, yeah, it seemed easy for me at first sight. It seemed to me like common approach. But yeah, I figured out the sample one is my approach. It was working fine, but once I gave it my real input, I was waiting and waiting. So I had to change my approach.
Yeah. Can I go for the first one?
All right.
All right, let me share. That's part 2. Here's my part 1. Can you see it?
You and your love and
Yeah.
9.
Oh yeah, I do 999. Just slam the 9 button. Why do 2 buttons? Why do 1000 when you can just slam the 9?
All right.
All right. So, anyways,
I'm gonna get your t-shirt just full of 9s.
the whole thing, right? It's gonna just rows. All right. So for importing my data, I ended up. So I imported it. I split it on each line, and then I mapped through, and I had to split based on each character in each line. Why did I do this? I didn't actually console log it. I do have it maybe in the next one. No. Let's see. So let me console log my input just to see what I was working with. It might take a minute. Okay. So I ended up with everything separated, just a map of numbers.
I don't think you need to split because it would make sense if you needed to split like 2 numbers into a single number. Oh,
What am I doing? Yeah, so now I have it like this.
okay.
I probably didn't need to split it here. I could just have an array of strings, but I wanted numbers so that I could deal with them individually as numbers for comparison.
Oh, because you want to split it into arrays and then you want to take the array and convert it into an array of numbers? Is that what you're trying to do?
Yeah,
Okay, gotcha.
a little bit
You
strange,
want an array
maybe.
of numbers. Gotcha. No, now it makes sense. So you did need the split then.
Yeah, my whole thinking on this one, I had to learn new things just for part 1. So this is the first problem where part 1, I couldn't get with just my limited knowledge. I had to Google and learn new things in order to solve part 1. But I was close, and I'll explain what I was missing and why that was important. So now that I have my input, I'm gonna loop through. I have my J's. What am I doing?
Looks
I'm
like
gonna
J's
ignore
are
that.
the rows and the I's are the, or the I's are the
Yeah,
rows. And
so
J's
my
are the
I's are my rows, my J's are my columns, just to help me organize my thoughts while I'm looping through things, because I'm gonna have to loop this way and that
You
way.
could have called J's columns and I's rows.
Yeah, that'd be a little bit confusing though. I wouldn't want to do that. All right, so now I'm gonna set my total to just some arbitrarily large number. Alex likes that I just slam on the 9. I think that it takes too much effort to push 2 different numbers like this. I don't like it. We'll just do 9s. So now I'm gonna get my C is gonna be my length of my input. So my length of I's, how many I's I have. And my D is going to be the length of each row, which for this problem ended up not even being necessary really, because for the sample, it's 10 by 10. For the regular input, it's 100 by 100. Anyways, that's how many times I'm going to be looping. And now I initialize an empty array for my best path risk. This is what I was missing initially the first time I tried this, and what I learned by searching about Dijkstra's algorithm. How you need to keep the risk for each location that you're going to know if it's the best path to that specific location somewhere in the middle before you get to the end. All right, so now here's the meat of my problem. I have a check neighbors function.
Yeah, the check neighbors most of the day, no?
You gotta check the neighbors.
Yeah, the stalactites to check the neighbors.
You gotta
We
check
had-
the neighbors, the Dumbo
We
octopus.
had the smoke clouds or whatever. We had to check the neighbors.
Why not reuse my check neighbors? All right, so now,
Stupid neighbors. man.
so my check neighbors accepts 3 arguments. I'm accepting I, J, and my total count. So let's see what's happening here. I should have made comments for this day, but I didn't. So I just gotta work my way through it. So now I have a few different checks at the beginning of my function. I like to do my checks like this. So I'm checking if I don't have an element in that I. That means that row is empty. Then I'm going to add in a row into my path, into my.
So if,
Yeah,
if it
yeah.
doesn't exist, you're
So
gonna create it.
if it doesn't exist, I'm going to create it. I'm going to add an empty array into that row of my best path risk array. So we have to do this just so we can get each row initialized. Now I'm going to check my J value. So if I don't have an element in that J value, so that specific index in that row and that column of my best path risk array, I'm going to add in a large number. My favorite 999 number. Okay, and now let's see. Now I'm going to do another condition here where I'm checking if my current count, so the current total that I am at, if it's less than the value that I have stored in my best path risk array, then I'm going to update my best path risk array with that count. That means that this path that I am on is currently the best path to that specific location. If it's not the best path to that location, I'm going to cut off that path right there. I'm not going to continue because that path is not going to be a winning path. It's already failed to get the most efficient path to the current place where it's at. So I'm going to return from there. I can ignore wherever that path is going. It's not the best. So now I have some more conditions. I'm checking if my I is, okay, I'm checking if I'm at the very bottom right corner, the final destination. If I am there, and if my current count is less than my total, then I'm going to update my total. That means my total is a new winner, a new best path. So I'm going to update my total and I'm going to log that total. It's a new best path. If it's not, so if I get to the end and it's not a new best path, I'm going to return because that path fails. You follow? So I'm checking a bunch of different paths at the same time, and I'm cutting off the ones that are less efficient. And now I have a lot of recursion going on here. I'm going to check if, what am I doing here? So if my element to the right of the current space that I am in is greater than 0, why am I checking greater than 0? everything's a 0.
No, there's no zeros.
Everything's greater than 0. So
Right.
if it exists, I guess. I'm just checking if it exists. I think that's what I'm doing. So that I don't have to have a check to make sure I'm not on the very right side of the array. I think that's the point here is I'm checking if the next element exists.
Yeah, I think you could have just done it whether or not J is, if you're doing
If
plus,
it's an element,
if
yeah.
it's less than J, the length of J, whatever
Yeah,
the array,
Less
I,
than D.
the length of input I.
Yeah. So
Anyway,
yeah, I can do that. If I think J less than D. My D, I think, is what I says
no,
input
I
of.
already said it.
Yes.
Okay,
Yeah, so I could do that one for here. That would be the same thing. I'm just checking if it exists.
gotta use more than one letter for variables, man. You're killing me.
Especially at first is IG, then it becomes CD. It's like, wow.
Where?
On the top, I think.
Because you have I, J, and then you have C, D.
Oh, I always
It's like arbitrary.
I always use, so I and J are always for loops. C is always for my length of an array, and if I have another length of an array, it's always D. I always keep the same thing. I know I do a lot of these, but if you notice, like my old code, it's always these same ones. Like I and J always mean the same thing, and C and D always mean the same thing. So to me, it's okay.
Yeah.
I don't know. Yeah, not very readable. So yeah, if the element to the very right exists, I'm going to call my check neighbors function, sending in that element. So my current I with my J plus 1 and my current count, and I'm going to add to my current count the value of the next of the element to the right.
Ah, so it'd be D minus 1
Yeah.
for line 40, D minus 1, right? So you're doing J plus 1. And D is the width.
Yes.
I'm already getting confused. with these letters. But anyway.
Yeah, so D is the length, so I need to make sure it's, yeah,
One less
one less than the length.
Cool.
Well, so, okay, so that checks the right element.
Yep.
Now I need to check the other elements. I think here I'm checking my down element.
Hmm.
And actually, the original code that I tried to do, I thought based on the sample, it looked like the path would only ever go to the right and down, to the right and down, down, right, down, 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 right, right, right. But apparently that was not the case.
A little bit deceptive.
So I had to add in check conditions here, or checks for all of the different neighbors. So left, down, up, and right. And that's what all of these are. I'm not going to explain each one individually, but basically I'm checking the right element, the down element, the up element, and the left element. And I'm gonna use recursion to check through all of those different paths. And I'm gonna get the best path risk to see if I'm on the most efficient path to that point in the map. If I am, then I'm gonna continue following that path, just branching out from that path. And if I'm not, I'm gonna cut off that path. So essentially, I'm gonna find the best path. My best path risk eventually is going to be a map of the entire map with the total risk level that it takes to most efficiently get to each point in my map.
Yeah.
And that was the one thing that I was missing when I initially tried to do this problem, just on my previous knowledge, is I just needed to implement the best path risk. I was trying to just use recursion to go through every element and only calculate the total at the very end. And that was so many paths that were not getting cut off. That it was very inefficient. My code took forever. So this
Well, you
allowed
gotta
me to cut
create-
it down.
You have to create a criteria as to like what paths you keep and what paths you prune out.
Yeah.
Dijkstra is a very good way to prune
So
out. It's a very simple way to prune out, right? You just keep track of what the best.
Is this a correct implementation of Dijkstra, or am I missing some parts even? Because it seemed very simple.
No, for the most part, yeah, the most part you got it. I mean, the idea of the Dijkstra is you flood everything with the highest risk possible, which for yours is 9999. And then as you visit each one, yeah, you calculate the risk of going to this neighbor, and if it was higher or lower than before, then then this is a good one. If it's higher than before, then it's kind of pointless. And so as you flood everything, you basically get a good map as to the cost level, I guess, you call it, to go to
get to each location.
to get to every location from the beginning. At the end, what the criteria for this one is you just keep track of count, and as long as the count is less than what you're looking for, then you found your path.
Yeah, so one weird thing that I did, I think, is I didn't end up like saving the best path anywhere.
Sure.
I just ended up console logging all of the best paths to get to the bottom element. So my final looks like this, where it just starts printing out a bunch of numbers. Oh, it found a path to the bottom. Oh, it found a better path to the bottom. Oh, a better path. And eventually the bottom, the last one that prints out is going to be the best path to the bottom.
Yeah.
So for the sample, it must have been 40, I guess.
Yeah.
Yeah, and actually, this is a little bit slow for my full input.
What's a sample?
Oh,
They give it to us.
How much time for your real input?
Let's check. I just started it. It takes a few seconds. Boom.
Yeah.
Looked like maybe 7 or 8 seconds to get to the final answer. It got that first, it was weird because it got that first initial value like right away. And then to find the more efficient ways, it was slower.
So can you explain one more time why you are checking the up and the left?
So because if I remove those, then my code fails. I get the wrong answer. Because apparently somewhere in the map, there must be situations where going up and going left.
It doesn't
more
only
efficient.
go down and right.
So
like
let's
the
see.
Sample.
You can see here, my final answer was 527. But if I run it, I get 531 if I don't include the bottom and the left and up.
Right.
And I was able to, I tried inputting 531, of course, and it was the wrong answer. So then I found, let's see. Oh, I must have deleted it on accident, but I created my own sample inputs where I had like a path of like 9999999. And then like I created my own path of like ones in the middle that snaked around. And my initial code without counting for zeros and ones is not getting it correctly. But, or without counting for bottoms, or sorry, up and left was wrong. So I needed to add that in. So it was a lot more recursion, but it was necessary in order to solve this problem. At least for
I'm
my.
assuming maybe, sorry.
Yeah.
But I'm assuming maybe on the top, it's not starting from order, like it's going maybe diagonally and it's skipping some of the cells, maybe. So that's why you need to go up and left to fill in the skipped cells, maybe.
I don't think so.
Because my approach is different and it entirely relies on the bottom and right approach. Yeah, and if there was a path which uses up or right, my approach should not have to work.
Might have had a different problem set that didn't include it.
Can you try yours with my input?
Yeah.
Let me send you my input and see if you get the same answer.
Yeah, let's see.
I'll send it to you on Discord.
Okay.
Let me stop sharing.
So I'm assuming maybe you are going diagonal and there's some left on the left side, maybe on the right side top. So you need to fill those in.
Alex, apparently too, had some case where it was more efficient to go left or go up.
Yeah, I originally started mine following the sample, thinking it's only going to go down and right. And so I created an algorithm that only goes down and right, and it was too high.
Yeah.
So I was like,
Mine was barely too high. Like you saw, when I did it that way, I got 531.
Right.
Whereas my final answer was 527. So it was 4 more efficient to go probably left somewhere or go right somewhere or go up somewhere. Can you try yours? I just sent you my input.
Yeah.
well, let's go over the Python code before you change too much. Let's go over your code and then we'll run your code with Scott's input and see if it runs the same numbers.
So are you done, Scott?
Yeah, I'm finished.
Okay, I will share my Python then. So this is my final answer, but before that, I will show my attempts. So this is my honest approach with breadth first search, like without searching anything online. So I thought about doing a breadth first search on the sample input. It took me like 10 seconds, but it was fine. It was getting the answer right. So basically, with breadth first search, I started exploring every cell, like from right and bottom, every 2 cells. And as I explore the neighbors, I also keep track of its history, since similar to what we did with another problem, like keep its history. And every time I was calculating the length of that history, and if there's any other same length with a lower sum, I was assigning that lower sum pass as the optimal pass, and so on. I was exploring every cell. I think before optimizing that, I was just going like until I went to the last cell. I was exploring every possible pass and keeping its sum, and then I tried to optimize it to get my real input to work. But still, my real input was taking too long because there were too many possibilities to go to the last, like bottom right. So breadth first basically did not work. It's my real input, and
Well,
then I
breadth
tried.
first, did you always eliminate where you came from?
Yeah, on that queue, I think I was adding only its neighbors to the queue, not the same.
No, I mean like where you came from, how you got into that queue. Like if you came from the left and went to the right and then searched the neighbors on the right, you don't want to go back to the left.
So what I was doing was I'm starting at 0, 0.
Mhm.
So to my queue, I'm inserting my 0, 1 and 1, 0 and popping this one. And next one, I'm going here and inserting 6 and 3.
But not one.
And after this, I'm going back to this one because after this, I added this, right? And after this, I'm adding this 3 and 2.
Oh, okay.
So yeah, like that.
Okay, so you're only going down and right, so you don't have the possibility of going
Yeah.
backwards because you're only going down and right. Backwards
Yeah.
has to be left and out. Gotcha.
Yeah, for the sample one, it gave me the output, but for my real input, it was way too many possibilities. I tried to optimize in many different ways, like keeping only the minimum 3 or 4 possible passes, but still. So I tried to with Jigar algorithm.
Extra.
It also, yeah, Dashgar. It also gave me answer for the sampled one for the real input. I couldn't get to the end because here it was similar to breadth first in mine. I was exploring every possible cell and I was not eliminating anything. So still there are too many possibilities. My optimization for this one still didn't get it. And at the end, I end up with another approach, basically dynamic programming approach. I end up with, which was much shorter time, execution time compared to graph traversing. So dynamic programming approach basically lies on the idea of finding the closest path to any given cell in the graph. So let's stay with this one. Now, one by one, I start determining the least sum of traveling to any neighbor and so on. So for every cell, I have the least amount of the least sum required to go there. How am I doing this? For any cell, there are only 2 ways we can go to, except these ones and these ones. We can all, the other ones, there are always 2 ones. We can come from up or from left because we can only go to the right and bottom. So I'm starting at 0, 0, and I'm checking my neighbor here. For these ones, I'm adding an extra list here, extra array with filled these values on the top and filled with these values on the left, because these ones do not have any value on the top and these ones do not have any values on the left. So initially I'm filling them with 1,000. So for this one,
Just kidding.
I have my 1,000 and my left is, I'm starting actually with 0 and my top is 0 and my left is 1,000. I'm assigning the least amount to this array. So I'm creating a new array and I'm assigning the least amount of sum to this cell, 0. So next I'm going to 1. On the top I have 1,000 and on the left I have 0. And to 0 I add my current cell, which is 1. So this one will be 1. The least amount of sum to get here is 1, right? And I go here. Here also I have 0 on the top, thousands on the left. I have 1 here. I got to this one, or let's say I go to 3. For 3, I can come at 1 on the top and 1 on the left. So both actually will give me 4. And I go to 6. I have 1 on the left, 1000. 1 is the least one, so I add 1 to my current one. So basically, yeah, like this, I will determine the least amount for each path by finding the minimum from the left and the top, and adding to that minimum my current index. Gives me minimum sum to get to the current cell, to this cell.
What is the 1000 for?
1000, you can set it to any number that should be greater than infinity, similar to infinity, because we do not have anything to compare the ones up.
Oh,
Right.
okay. It's just it's like a border then, so that you don't have to
Yeah.
tweak your algorithm.
Yeah, I don't have to check for the edges like undefined or stuff.
Right.
So I'm just giving 1000, and it's always higher than the left one. So I will most always take the left one. It's just for the edge case, not to go outside the border. So it's linear too, I think. Like I'm looping once through each cell, and as I go, I am determining the minimum sum to get there. And once I reach here, I get my minimum sum immediately. So that was my approach.
Good explanation. Thank you for creating this.
Clear, right? Is it clear? Any questions?
No, I did the same thing with one of my approaches, except I did reverse. I start from the bottom right and I go to the left, to the top left. So I mapped basically the distance, the cost distance from the finish. But it doesn't work at the end of my problem set. Unfortunately, because again, it predicates on a single direction of movement, or a single, bottom left or up right, whatever.
So that, yeah.
So anyways, but yeah, I think there's an actual, do you remember the term for this algorithm was like Fulman-Hom? I'm pulling this out of my butt. I believe there was like a 2-syllable first name and a dash and a 1-syllable second name. That's the algorithm credit.
I found this was a dynamic programming approach, like to find the sub problem and solution for that, and build on top of that to get a solution for the larger problem.
Yeah, but I mean, there's an actual term for the one that we're doing. We're basically creating kind of like a cost map.
Yeah.
Because at the end of it, you're getting the cost to get to a certain spot from a given origin. Right, and so at the end, it's you get numbers in your boxes, and like you said, at the end, you end up with a single number in the corner. And that's the number of the cost to get there, the cheapest cost to get there, if you only went down and to the right.
Okay.
Cool, but that's what you used, and that worked for you, huh?
Yeah. So should I check Scott's input too before we move on?
Well, let's see your code. Let's see how you implemented this, and then.
Okay. So this function is for my part 2, not yet, but this is for my part 1. Okay. So first of all, I figured out how to debug Python 2. And I will sticking with Python probably for the rest until the end of the puzzles. And I couldn't work my importing inputs with the debugging. So for now, I have all of my input in the same file to make it simpler for me. So I'm passing my string to my lowest risk level pass function, and I have my new pass here. New pass, which will be the matrix. It will be an array of integer arrays, basically. So I'm starting to loop through my paths here. And first of all, I'm populating my matrix, and then I'm adding my coordinates. So this will be my new, it's supposed to be my new matrix, but instead of working with matrix, I'm choosing to work with the coordinates as a dictionary. So I have my coordinates as a dictionary key and values as the minimum sum needed to get there. So I'm populating my coordinates here, and I think I'm setting all of them to 1000 at the beginning. And I'm adding, so I'm generating my matrix here. This one is irrelevant, part 1. And I'm starting looping here. From the left top, I'm starting to loop, and I'm getting my bottom value, which is this one, y minus 1, and previous, which is x minus 1, and current, which is xy, like yx. So these are the coordinates, right? And I have my minimum, which will later be set to the minimum of the bottom and the previous values. So if I'm on the start point, I'm setting my coordinate, my current sum to get my current points to 0 because I'm on the start. And I'm also setting my value to 0 on that new pass. And if I'm not on the starting index, but if I'm still on my initial line, on my 0 index line, I'm finding the minimum of my previous value and 1000, because if I'm here, I have to find the minimum between my previous index and the up is 1000. So I'm finding the minimum of them and setting it to minimum. So these are the ones. I will explain those two later. So after I got my minimum to this coordinates dictionary, I'm setting the current point, the sum of minimum, and my current index value. So I'm getting their sum and setting it to my dictionary value for the current point. So if I'm on the x0 coordinate, which means if I am on any one of those here, I'm comparing 1000 with the higher value, to the lower value, and setting my minimum to that value. And if I'm anywhere else, I'm comparing my previous with the value at the bottom index and setting the minimum to the lower one. And I'm setting my coordinates current point to the sum of my current index value and the minimum to get there. After I loop through, I'm getting all the values from my dictionary or coordinates and converting it to list or array and returning my last index value, because the last index is my right bottom, and I'm returning that value to get there.
Okay, cool.
Your variable names confuse me a little bit. Bottom and previous. Current, I
You.
Bottom? For bottom, I would rename to top, because it's the element above, right? And previous, I would rename to left. But
Oh, I
bottom
think,
was the confusing one for me.
I think it should be top. Yeah, thank you.
Okay, it's just a name.
Because on the logic, I remember I tried to come from this right to
You were starting from the
yeah.
Oh.
On the logic, I tried to go from here to here, and then at the end on implementation, I changed it to go from here to here. So yeah, the sample, changed. I think I didn't take.
That's the correct answer for the sample.
Part 1, yeah, because
Part 1.
Yeah.
Oh, we're part 2.
Yeah. So Scott's answer. So I'll try Scott's input now.
Did I send the entire thing? Did you get it?
Yeah, I got it. Opening it now.
It had to send us its own file.
So I have to paste it in here.
Looking good.
All right. Your file size just quadrupled.
Yeah, 500.
Ah,
Is that the not the right one?
that's not the right one. That's the one that,
Yeah, that's just for
that's the
sense.
one only going to the right and down, but that wasn't the most efficient for mine. But for yours, it was. For yours, that worked?
Remember, we have different,
Yeah.
it's very possible we have different problem sets, and some of us may not have.
It's
Yeah.
Bad name. Why didn't I get that one?
It's interesting though, because I thought like, usually the problem sets all have like the same kind of gotcha in them.
Yeah.
Like if there's one like trick thing, I thought all the problem sets had it. So it's weird that it's funny to me that Farouk's would not have that.
Hey, Farouk, can you send me a copy of your problem set?
Yeah, so I try not mine now. This is mine here.
Because I actually map it. So you can see.
Oh, you can see it.
Uh,
Visualizations.
The part 1 here. Yeah, can you guys see my browser? No?
No, we only see your VS Code.
So yeah, my right one was 741.
Okay,
Yeah.
so
Yeah.
so it worked on yours. That's
Yeah,
funny that yours didn't have the.
I wish I had your problem set.
Yeah.
Because it would have saved me a lot of time. But then, I guess.
Yeah.
Interesting how it works for some.
Yeah. It's interesting that we had different kind of cases in our problem sets. You didn't
Yeah.
need to care about bottom or left and top. Cool.
Yeah, if you could either send it through Discord or paste it into this chat window here. I don't know.
I shared it on the Discord channel for all you guys, if you guys want to check. Yeah.
Thank you. What would you have done, Farouk, if you had, if yours didn't work and gave you the wrong answer? How would you have updated it to handle those extra cases?
So yeah, I would probably check for my direction, probably update it, or let me print out my it depends actually. Like, did you manage to figure out the exact paths,
Mhm.
Scott? Like, did you really see it's going up, or
I didn't visualize everything, but that's essentially how mine works, is it just
No, he made
spreads
it,
out.
if I'm correct in interpreting what you said, you made a sample that did have up and down,
Oh,
and that's how you confirmed your
Yeah.
theory.
yeah.
So he created a smaller sample set to prove this theory that maybe it goes up or to the left, and the sample proved this theory. I'm just gonna give you a bunch of numbers.
Yeah, so Farouk, I got 741 for yours, but it really means nothing because I can't see it.
Yeah,
And
so I have mapping on mine, so we can see it,
cool.
see how it ends up.
So I'll see yours then.
Yeah.
okay? I'll stop.
Okay, so mine's kind of a mixture of both of yours. I think it might be kind of interesting to see. Let's see which window is it? But rather, I did what both of you guys have. So let's go to the bottom first. So the bottom, I did, what I call a heat map. But first, or at least I thought I did. Oh, you know what? I saved it on the second one because okay, so here's a funny thing. So when I did 15.1 first, I actually did it. Okay, there's the code at the bottom. I actually did it similar, what I call a heat map, but basically a risk map. So I'll go from the bottom right up to the top left, just like Farouk did, mapping along the risks and tallying up the risks as you go. Rather than having a flat map of individual risks, it adds up all the risks as it goes to the top left. And then you find out, basically by only saving the least from the top and the left, and only saving the least number as you go up, you find, the quickest path that way. That's only assuming you're going left and right. Or sorry, you're only going right and down. But unfortunately for mine, it didn't work. But there was a bug in mine.
So maybe it could have worked.
And it did work. Well, I got the right answer, but it doesn't really work, right? But I got the right answer. Because what had happened is my answer was only one off.
Oh.
Right? And in my problem set, my corner
Was counted as one.
was a 2. Right? And I had mistakenly, instead of assigning when I first started, instead of assigning that the value of when I first started with the 2, I mistakenly assigned it to 1, because before I thought, oh, I'm just going to add 1 to, because the original shortest path that I was thinking of was I was going to just use 1 and then just add everything to the 1 as it went up. And so my answer was off by 1. But then the real answer was also off by 1. So the real answer for me was like, let me see, it was 300 and something. Oh, 403. But after I fixed my algorithm, it ended up being 404. But the first time I went through, I got 403 because of that one off. Because instead of adding in the bottom corner, starting off with a 2, I started off with a 1. And so I mistakenly got the right answer. So I thought, awesome.
It can't be a coincidence.
I thought, awesome, this is awesome. Right?
It's gonna be quick.
Yeah, it'd be quick. So I went to part 2 and I could not get the sample to work. Or maybe the sample did work, but I couldn't get my answer to work, right? I kept on getting like too low, or actually no, it's too high and too high and too high. And I was like, okay, there's something weird going on. Maybe it's going up, or maybe it's going, the answer, instead of going down to the right, maybe there are a couple ups and lefts. And so then I was like, oh, then if I were to redraw, the problem with the way that the original algorithm works is that as you're going up or down, depending on the way that you're combining your risks, is that you can only analyze blocks which have already been processed. So as I'm going through and I'm looking at left and down, basically, right? So I'm looking at, because as I'm processing, I'm going, well, let's start over. As I'm processing, if I start from the bottom corner and I go to this side, and I go up a row and I go to this side, and I go up a row and I go to this side, the only things that have been processed so far are to the right and to the bottom, right? I don't know what the projected risk is to the up or to the left of me yet, because those are in the future. I haven't processed those rows yet. And so it only assumes that, or only takes into account things that are to the right and to the bottom. So I can't take into account the ones that are to the top and to the left, unless I redo the risk assessment again afterwards, because then I'll have the first pass is like a first heuristic, and the second pass will be another heuristic. Alternatively, I can also do rotations. It's kind of a weird thing, a weird approach, but you can do a rotation where you take your map and then you start rotating it. You do another analysis and you do a rotating again. You do another analysis, you do a rotating again, and then you get all 4. As you do 4, you get all 4 in the correct analysis. I don't want to do that, especially since I already knew Dijkstra's algorithm existed, and I was like, But so what I ended up doing was, for part B, I did Dijkstra's because that's like whatever. That was like the easy to reach to thing. And then I went back to part 1, which I realized there was a bug. But instead of trying to fix it, I did the other. There's 2 great pathing algorithms. One is called Dijkstra's and the other one's called A*. And so I did the part B in Dijkstra and part A in A*. So you guys can kind of see the difference between the 2. Now, the thing with both of these though is that they're so common that I didn't really have to research or do anything else other than the fact that I can go to the wiki page, and the wiki page has pseudocode. Now the pseudocode, of course, isn't, you know, let's see this.
It's kind of hard to use.
Yeah,
Without knowing how to use pseudocode, I think.
well, yeah, it's usually very general, right? And so you have to translate it into whatever language you're using.
Yeah, that,
And then it uses like weird things like this, which, you know, not all languages use. I think P early language, no, Perl. Perl, I think maybe root, no, R uses it. I don't know. Anyways, but so I just took this, I copy pasted it, and then I translated it into Rust. But I try to keep as much of the original structure as possible, trying to keep it in a line fidelity so you guys can see how the translation went into the R equivalent. And so I'll leave this up here, or you can see it on my GitHub, but I'll leave the comments and everything on there so you can see how the translation went. That might be kind of interesting for you, or fun for you guys to see. It's not optimized because the way that they've done it, I would have used probably a different data structures for some of the stuff, but again, I wanted the priority to be try to stay close to the original pseudocode as possible. So try to keep it where I could at least.
okay.
The only thing I had to add was a heuristic. There's a heuristic function that they didn't include in here, but the heuristic function for us is really simple. The heuristic is essentially to tell A star what is like, if everything was really good, what would be like the ultimate way of finding this value? And the thing that we're trying to find is distance, right? And so what would be the ultimate way to find distance? And it's just Manhattan distance, I guess. Alternatively, I could have used, I guess, math and triangulate the actual distance as the crow would fly from point A to point B. But I just use Manhattan distance. Nice thing about Manhattan distance in our case is that the bottom right is always going to be the largest number, both in X and Y, right? It's always going to be like 40, 40, whereas everything else is less than 40 and up in the upper. So the Manhattan distance itself ends up being a pretty simple arithmetic. I don't have to do any kind of absolutes, anything like that. But anyway, so that's that. The only other thing in here is the version that they include in the Wikipedia has a reconstruct path. So instead of getting a total risk in our problem sense, they just have the path, what path was taken. And so at some point I have to unroll the path to get all the risk numbers and add them all up. So it's one thing I would have changed if I had just written this on my own, is to include the adding up inside the algorithm itself. But again, just to keep as much fidelity as possible. So anyways, so part A, using A star, I do my usual thing of trying to convert this
Vector of
yeah,
vectors of numbers.
bunch of essentially characters, right, into actual numbers in a structure of a vector. And then, but I need to pre-process it to what A star needs. The original A star algorithm assumes a flat path, not two-dimensional path.
Interesting.
Yeah. Well, that it's represented in a flat path anyways. But I wanted to do an X and Y, so I had to go back and instead of doing, a standard start as a single variable, in order for me to do it as a single variable, I wanted to use something easy to use, so I ended up just using a tuple or a tuple, depending on who you ask.
We don't have that in JavaScript, but
Yeah, I wish we did. It seems so useful. You'll use it all the time in Python and stuff.
It can be. I mean, the nice thing about it really is that unlike many other data structures, it's mixed type. So if you just want to cram stuff in, tuple. But everything else is like, oh, this is a vector of numbers. And I only use numbers. I can't put anything else in there. Unless create a struct. But anyways, which I did actually for that die struct. I'll show you the die struct in a little bit. But anyway, so that's the only change I made, or one of the only changes that I can recall that I made to the original one. So I had to prep it. So I turned everything into a a coordinate and the risk number that it was. Now, the other thing is that the algorithm itself, not only does it require a kind of a flat single value for the beginning and the end, but there's a neighbors that it needs to pick up. And instead of calculating the neighbors as it goes, because in a graph, the neighbors and the edges are already included, I had to pre-create the entire quote unquote graph for the A star to go through. And so I pre-populated my data structure with all the neighbors. So for every point, it includes the points, it includes the risk. So that's using points. For every point, it includes the risk and the neighbors. So that's the data structure. For every point on my matrix, it's the risk number and the listed neighbors. And that gets all fed into A star. And A star goes in, and A star is a little bit more optimized from Dijkstra's in the sense that Dijkstra floods the map. Basically, it's every point of every possible combination. And it does okay with it. Actually, it does pretty well because you can do some efficient caching if you know, that's one thing that I did with mine. There's some caching in it. But A star has an extra thing it adds called a heuristic. And the heuristic is something that it kind of uses to make sure that it's on the right path. And so it'll eliminate things that like start falling really far outside its possible realm of like, oh, this can't possibly be something that's close. And so the heuristic function is kind of key in the A star. And so in that sense, it ends up being a little bit more efficient, or can be. But of course, if your map starts doing a whole bunch of wild things, A star is not going to work. But ours seems pretty sane. I'll leave it to you guys to look through the wiki to explain to the A star, because there's a lot, quite a bit to it. But essentially, for the one that they have an open set. The open set is the places I haven't visited yet. They have a came from, which is solely a list just so that at the end of the thing, I can find my way back home when I get to my goal. I have the F score, which is a score including the heuristic. And I have a G score, and the G score is just a general score. It's a normal score with just the risks starting to be added up. Almost like what I had done before. You're just adding up all the risks as you move down, find the cheapest one, but there's a heuristic involved. So sometimes, you gotta be able to choose between left and right, or how far off you're willing to go into the weeds in order to find the shortest one. Yeah. Other than that, it's you find the one with the lowest F score. Okay, F score we'll look at a little bit later. If you've got to your end, then I'm just going to reconstruct my path, and that's what gets returned. But other than that, I get my nearest neighbor, or from my list of neighbors, I get the next neighbor. I generate a G score from it. If there was one that's already existing in the past, I get it. If not, then I'll have to create one. So I have a tentative G score, and then I have the G scores of all the neighbors. So for all the neighbors, I get their G scores as well. So far, we've only looking at their general scores, which is adding up with the risks. Came from just for displays. Before I go there, I'm going to create the little breadcrumbs of where I've been in the past to get to that particular neighbor, just so I can reconstruct the path if I find the end. And then the F score is included. And the F score includes that heuristic. So how far or close am I from that ideal path? And that's what I score, or that's what I store in my cache. And so the cache is going to help me in the future make decisions. So, I have two things that are pretty close, in terms of what I want to go, but the heuristic is going to pull me towards the right direction by biasing towards the shortest path, not necessarily the riskiest path. Or if the two things are more risky, then I'll try to find the shortest and so on. Or the least expensive, I guess, is more accurate. So once I get all those, then I just need to iterate through them. And what am I doing here? I'm just finding the last point. Remember that I'm following all the points and adding up all the points as I go along, all the way back up to the beginning. And so let's, oh, you know what? I gotta do this. I can't do this in the browser. Git can't run Rust, right? Give me 1 second. Oh, you know what? I can't run Rust on this workstation either.
Oh, we can't see it.
Let me try to get to. Think about this for a second. Should I install Rust? Maybe I can install Rust down here. It's not that hard.
It's not going to take too long.
I don't remember. It's been a month since I installed it on Windows. On the Mac, it was easy because I just used the casket, what do you call it? Brew, but then it took a while to download everything. That's the only thing. But Windows, I think, was pretty quick. So here we go, installing Rust after 20 or 15 days of running this. How could I not have Rust on? I don't. All right. Anyway, so let's install the 16-bit Rust. You can.
He's just showing us how to do because soon we might have a Rust project.
Yeah. The next project.
He's teaching us, he's preparing us for the.
It didn't save time altogether in the machine. You know?
Everything in Rust from now on. Front end Rust. Let's see. Let me see. Oh yeah, that's right. There were a couple different versions. The new version or the end of stuff. I don't really care. Oh, but maybe I do want the new. Let's see what happens with the regular MSV. So anyways, while this is downloading, so let's look at the second one. Because the second part of this question, they're asking you how take your map and make it 5 more this way and then 5 more this way, right?
Okay.
So you're basically making it 25 times larger than it used to originally be.
But every time you extend it like one,
Oh, that's
one
true.
to the side,
Yeah.
all of the numbers increment by 1.
Right.
And if the numbers go over 9, they drop back down to 1.
Right.
So for example, if the top left corner is a 1, on the next like chunk over, it'll be a 2. On the next one over, it'll be 3 and a 4 and a 5. And then, but then it also increments when you go down too.
Right.
So the bottom right corner is going to be added up like what, like 8 times the initial? I don't know. They're like
5.
the initial value plus 1, 2, 3, 4, 5, 6, 7, like 8, I think 8 times. So if the
Okay.
initial like 0, 0 value is a 1, I think it'll be like a 9 at the very bottom. So yeah, the whole graph is just, the whole map is just expanded to the right 5 times and down 5 times. And so now you have a 5 by 5 grid that's, yeah, a lot bigger than the initial size, and all the numbers incrementing too.
Yeah.
So it took a little bit of setup just to get to the input that you needed now.
Okay. Downloaded it. Now let's see if it'll run. I think that might have been the same window. Okay, so now we get the Rust compiler in. Oh, but now I get no. Let's start with one of your guys' solution while I also download the Git repository so I can make the code. So it's being a little bit more involved. But anyway, that was so my first problem set. I use A star.
All right. Probably maybe a little overkill for part 1.
Yeah, maybe, I don't know. It was easy for, it was easier for me just because I
You're
can-
familiar with A-star, you've used it before.
and the pseudocode's already there, so it's more just jogging my memory as to like what order to do things in.
Okay.
The difficulty, of course, was the translation of like, oh, how would Rust do this? And how do I fit that in one line? There's a couple places where I had to break it up in 2 lines, but and I'm sure I fudged things up too in terms of like idiomatic Rust. But
Well, Farouk, my part 2 is a little bit of a mess, so how about you go first?
Right.
A little bit, but it might be a complete mess.
Like 3D. Like 3D.
For my part 2, it's the same calculation like path finding function, but I have added a extend map function which will extend my input 5 times to the bottom and 5 times to the right. So it's the same function as you guys can see, but here I have my extend map in place, which will take my matrix as an input and spit out another larger matrix. So let's go inside the extend map. So first of all, weirdly, I had a 1 empty array before on my matrix here, and I am removing it first. Give me a second. I think here you don't have it. So it was because my thing was here. So I'm first creating a length for my row, which is 5 times larger than my initial length of the first row. That will determine my end row. And then I'm creating my raw length. I'm getting my raw length, the initial raw. If it's 10, I'm storing it as 10, my column length. Most times they are similar, but to make it more specific, I'm creating different variables for both values. And first, I am incrementing my input vertically. So let's say if it's my input, I'm incrementing it vertically like this 5 times without these spaces. Like I'm incrementing numbers too, but basically like this, I'm incrementing my input. And once I increment it downward like this, in the next iteration, I'm incrementing it to the right. The way I increment is, first of all, vertical, and every time if my index, vertical index, goes over y, which is 10 in that sample input, if it goes over 10, I'm dividing that point by 10. And if the division value is higher than 1, which means I'm over than the first given input, I'm getting my previous y. Previous y means I have to increment, right? I have to get that first value, which I have to increment by 1. So if I'm on the 12th, row number 12, I have to get the value from the row number 2 and the similar x index. So here, my column length, I'm subtracting my column length from my current index. So if I'm 12 now, my column length is 10, it gives me 2. So I will get the value on the second row on the same x value. And if it's equal to 9, I will append 1 to my temporary array. And if it's not equal to 9, I will increment it by 1 and add it to this new temp array. And at the end of my loop, I will append it to my initial grid array, this new array. So I am adding a new array to my matrix until it reaches the 5 times length first. And once I'm done with it, I'm working horizontally. So this is for my vertical and this is for horizontal. And every time I have my end row. So end row represents the 5 times length. Yeah, if it goes over, I think I don't really need it. Let's see. Oh, so if my x goes over end row, which is 50, I'm continuing, I'm ignoring it. Okay, let's come back to this part later. But
you finished last night.
Yeah.
Yeah, you did this yesterday?
Yeah. So here,
Nice.
yeah, let's come back to this later. But here with the horizontal row,
We
I'm
lost
doing.
you, Farouk.
Huh?
Yeah, Farouk, we can't hear you right now.
Oh. Sorry. How about now? Can you guys
We
hear
still
me?
can't hear you.
No?
Did you change the volume?
No, I did not change the volume.
Weird, you're not muted, but we can't hear you. Alex, did you change something on the volume?
I don't think so.
Can you? Okay, let me rejoin.
My volume up just to check.
Rejoin.
Farouk, can you talk?
Whoa, that's me picking you up again.
Sorry.
Sorry, I did mute.
I will rejoin then.
I think it was something with maybe with your volume got muted. I don't know.
I don't know,
Oh,
but he, yeah, he's gonna come back. So while we're waiting,
you got Russ?
here's his map.
Oh,
There it
you
is.
got it going. So his just goes straight, right? Yes, no curlbacks.
See in a second. I have it pulled up, but I haven't actually looked at it yet.
Okay.
So.
Can
Hey,
you
welcome
guys,
back.
can you guys hear me now?
Oh, we still can't hear. You got-
So maybe isn't muted.
No?
Ah,
Oh, okay.
somehow I must have muted, my bad.
Oh, okay. So can you guys hear me now? Fine.
Yes, we
Yeah.
can. Sorry about that.
No problem. So for my horizontal row, I'm doing a similar approach. Once I go over the length of my initial row, if it's 5, if I go over 5, if it's 10, if I go over the 10, I determine it by dividing it with the initial row length. And if it's higher than 1, which means I'm over it, I will get my previous X value by subtracting my initial row length from my current index. And if it's 9, I will append 1 to my current array. If it's not 9, I will increment it by 1 and append it.
Okay, so this was all just set up to get the
Yeah.
input array.
Yeah, to increment. I think that's the only difference in part 2 for me.
Right.
Like, was a different input increment. I was actually really curious to see how part 2 would be for a problem, which is part 1 is so difficult.
Time 14.
Yeah.
Yeah, I updated my input like this, and the rest is still same from the top to the bottom.
So Farouk, I have your first one mapped out. Do you want to see it?
Yeah. Okay.
Let's see. Okay, so you see my gridded
Oh, I
numbers.
see all the stars.
Yeah, so I'm going to zoom out a little bit. Oops. And then we're going to do, oops. Yep. Find on the start. Find on the start to highlight the path.
Yeah.
So there's your
Oh,
path.
Whoa, this just goes to the right and then just down? Oh,
So it
no,
doesn't
the
look
preview's a little
like-
bit weird. The preview only shows like the first 50 rows
Yeah.
or 50 columns. I
So
don't see any up or back.
How about yours or Scott's?
Well, you guys go.
right,
Maybe, yeah, let's look at ours after.
and there you go. So in the bottom,
You do go up.
you do have an up.
So how did you handle that?
I don't know.
You did go up.
No, you can you yeah, move that scrolling.
Are you sure this is his and not yours or mine?
We can run it again. Yeah, I could run it again just to be sure.
8 to 8. Let me check.
Comment is again. So we're getting this from far.text.
Awesome.
And just to verify far.text.
8, 8, 8.
I like the fact that it worked out so it's far out at the end.
No, I think that's mine, yeah.
So yours ends in at 828,
Yes.
starts with the 919.
Yeah.
Okay, and then we'll run it again. Far out.
Or can we just verify that that's what we had on the final map?
Oh yeah, we can do that too. But it's running now.
Oh,
And it just-
okay.
It just finished. Oh, so 828. Yeah, 828.
So how did Farouk get the final answer?
So at some point you were able to go upwards.
So when I'm calculating the minimum
Oh.
sum to get there.
But you're looking at the left and up, right? As you're going down from the top right,
or top left.
Yeah.
Because you're starting at the top left, right?
Yeah.
And your algorithm, you're looking at which neighbors?
So left and top, x minus 1 and y minus 1.
Right. And so then, oh, so then you are considering those, but then how do you consider where to go next? Oh, because you're looking through history.
I'm still confused because
If you're looking through
But
history-
this is your algorithm, right? This
Oh.
is your algorithm
That's
draws a
right,
map.
that's right.
but we're comparing Alex's algorithm using your input and
So all we have to know is
No. Yeah, let's see if
these
this is the
numbers add up to these four numbers is essentially the question. And the answer is yes, because you have, right? Because you have a 6 with 2 1s to make it 8, and you have an 8. Then down here you have 2 8s.
so it's the same.
So can
It
we
doesn't need to go up.
It doesn't need to go up. You could have just flat through the 8s and gotten the same score, right?
So it's the
Because
same score.
the tops, these cancel out the 2 8s you would have skipped.
Yeah. Because
So this
Farouk's
is-
worked on his, but it didn't work on yours.
741? Did you get 741 too, right?
Yeah, I should have. Like, I mean, yeah, 741.
Okay, so yeah,
Or-
probably
You
that's
got
why.
lucky. You got lucky in the sense that it didn't matter for you whether or not you went straight or whether you went up.
Mm.
So Farouk's code failed to get the right answer on mine. Can you try yours on mine to see my path?
Your problem set?
Yeah.
Oh, okay.
Let me go to this.
On Discord.
Okay.
Because yeah, Farouk's was like 4 values, like 4 numbers too high for the final answer for mine. So mine has somewhere where going up or going left is more important. Whereas Farouk's kind of had an optional up, but it didn't really matter.
Isn't that then the problem, like violation of our rights by giving a wrong direction instructions?
I don't know, man, because remember the first one, I got it right, even though there was a bug on my code.
Well, the instructions never said that you only can go to the right or down.
Yeah, that's true.
I think they
Sample
said,
input- The sample answer showed it like that, but the sample was only 10 by 10 also.
I remember one day also I had a bug, but still he passed for part 1. And then on part 2, same, it wasn't passing. So I realized I had a bug in the first part.
So why was part 1 passing?
Yeah.
It's confusing.
Just because the first time, I think in part 1, I wasn't checking one clause or stuff like that. So, but luckily it didn't happen.
Let's see where
If Farouk is far out, am I gonna be scout?
you are going to be scouts. You're going to be
Or-
go out.
Sco out?
Let's actually find you now. You can see my screen, right?
Yeah,
So there's go
I'm
out.
sco out.
So there's yours.
Oh, I see it.
Also a little bump.
Yeah, oh, and that's a significant bump too.
So to skip the 9, you went to 2 1 1.
So that's
2, 1,
definitely
1, yeah.
necessary, yeah.
so once you're going up, and is that it?
I think so, because I remember my answer was, I
I
went to
went
left
right
here. To avoid that 8, you went to the 4 1.
Yeah,
But it shouldn't be too far off. It could be, a bit off, but probably not too far off. And then the rest of it is pretty standard.
yeah, then you should have my final answer, I think it was 527 maybe?
7.
Yeah. Farouk, you got lucky, man.
Well, would it have worked on part 2? If you double the number, or no, you didn't double the number, you just incremented that. So I guess it doesn't really matter since you just increment the numbers.
Could be, but because some of them drop down to 1s and 2s, it could
But-
play.
Well, that's true.
But yours had 527, right? When I run yours, I got 531, no?
Yeah,
Yeah,
So I was off by 4.
yeah.
right.
But here it seems like you are saving a lot more by moving right.
Well, yours, you could be going a completely different path too. Because if you're not going up or left, then maybe you're going a completely different path. I don't know.
No. Anyway, moving on. So we had, so did you guys both do part B or it's just for,
I didn't do part B yet.
okay.
I did it.
Oh, it's painful.
Oh, I'm embarrassed. Bad one.
So was it clear with mine? Do you want to reshare it or?
No.
No, it's okay. You did a good
But
job.
you got the answer for it, right? Because you didn't change your algorithm, you just changed the playing field.
Input, yeah.
All right, so for mine, I also, of course, had to update my input. So for mine, I did it backwards from Farouk. Farouk did the verticals first and then the horizontals. I took care of the horizontals first and then did the verticals, but essentially it comes out the same. Well, the first thing I did, I hate when it pops up with things.
Yeah.
So the first thing I did is I added all of my new rows. So I just added an empty array for all of my new rows that I will need. And then the second part is I extended my initial input arrays horizontally. So to do that, I had a loop inside of a loop. So I looped through all of my initial elements, all of my rows, and then looped through all of my columns. And I added to, let's see, I added to the current row, I added, yeah. Okay, yeah, so C plus J, for example, would be the row or the column right next to my initial one that I have. And then I also multiplied. So I have C times 2, C times 3, and C times 4. Remember, C is the length of my array. So essentially, it's going to add in the element 1 grid over and 2 grids over and 3 grids over. So I'm adding the current element plus 1 for the grid that's 1 over. I'm adding 2 to the current element for the one that's 2 over, 3 for the one that's 3 over, and 4 for the one that's 4 over. So I'm just extending horizontally like one element at a time. So I'm adding in pretty much 4 extra grids starting by the left element on each one. So they're all getting filled in. All right. Now that I have extended it horizontally, I now have a new length of my array. So now it should be 500 elements horizontal. Now I'm going to extend everything vertically. So to do this, I'm pretty much doing the same thing, except my I's and J's are backwards here. Instead of doing J times C plus 2 or whatever, I'm doing it with my I array. So, and again, I have to add the numbers. I have to increment the grid that's just below it is going to be incremented by 1. The grid that's 2 below will be incremented by 2. The grid 3 below incremented by 3. And up until now, I did not care about things going over 9. I just let things go over 9. So right now, I'm probably going to have numbers that are 10, 11, 12, probably maybe even all the way up to like 17 or 18. But I know that they're not going to be over 19 or even 18. So all I have to do is just loop through everything again and subtract 9 if it's already over 9. Check. If any element is over 9, I can safely subtract 9 to get it back to where it has to be. Did we lose Farouk again?
Looks like it.
I don't know when he left.
Let's just keep going though. We're almost close to 2 hours.
Okay, so now I tried to.
Or 3 hours.
So the next thing I tried to do is I tried to run my code from part 1 on this one using my very lame implementation of Dexter's algorithm. And I had issues. I kept getting some problems. I was getting maximum call stack exceeded because I was calling my recursive function too many times. So instead of trying to find a better algorithm, I just tried to hack my way through it just to get it to run. So in order to do that, I tried to add in some kind of little optimizations in order to limit my path range a little bit. So based on the sample and other examples that I saw, I was able to, I pretty much assumed that it was not going to go pretty much straight down and then to the right, or straight across and then down. I figured it was going to stay somewhere in the middle. So I tried to add in a little bit of a range to it. So I added these limiters here where if my I or J get way too far apart, then I'm going to cut off the path because it's probably not going to be correct. So I ended up doing if my I is greater than J times 5, or if my J is greater than I times 5. So that means I'm getting like too far to the right or too far down compared to where my other value is, then I'm probably going too far in one direction. So I'm going to cut it off. And actually I had to tweak with this because I set it at like 2 or 3 or 4 and it was getting cut off prematurely. So 5 seemed to be a good number. I don't know how much it actually helped. What actually I ended up needing to do at the end is I used a bunch of set timeouts.
Wow.
So this is super hacky, right? Huh?
That works.
It worked. So what I think was happening was that I think that each function that it was calling was kind of hanging and waiting for the result of the functions that it was recursively calling.
Yeah.
So eventually too many functions were open at the same time. So by adding a set timeout, what I think that allowed it to do was to close the initial function, because I thought that it was no longer waiting for a result from the function that it called recursively. So the initial one that opened all of the other ones could close, which allowed me to not exceed the maximum stack.
But they're also waiting as well. Yeah, all you've done is you made it asynchronous by putting this up timeout and putting a 0, and you made it asynchronous, but at
It
the same
worked.
time, it's like,
I don't really understand why it worked.
well, I mean,
But
what you
it-
say is true. As soon
yeah.
as you make it asynchronous, it just calls, check neighbors, and it just goes on its business, calls the next, so it just keeps on going. It doesn't wait
Yeah.
for the first one to finish before it goes the second one, and then the third one, and the fourth one, and then it's done. And like, okay, I'm done with it.
Yeah.
And then its children calls its children, and it kills itself.
This took me a long time because I kept getting this maximum call stack exceeded. And I knew that like, if it could just run, it would get the final answer because it worked for part 1.
All right.
And the only thing for part 2 is it's bigger. It's just a lot bigger. But yeah, so my hacky way was to be able to get my set timeouts in here. And it ran, it takes a long time. This is like a 10-minute long runtime. I think, yeah, I calculated it at about 9.5 minutes on my Windows machine. I don't know how it runs on this Mac. Probably similar. But at least it finished. And seriously, this was the first one of this year's Advent of Code where I was just like happy to even get an answer. Because I feel like for this one, I was punching a little bit above my weight class to even be able to solve this. Like it was things that I did not know how to do before. I had to learn how to do this, like pathfinding stuff. So I was just proud that I even finished this one, even if my answer is completely hacky and takes 10 minutes. But
Cool.
I was happy to get it.
I'm suspecting there might be something that's hanging up for you because it shouldn't have exceeded the call stack. I mean, it's a lot of calls, but it's not like more than the computer can handle, I think.
I don't know.
But that's interesting. Anyway,
It was.
but you got it to work
Yeah,
somehow
hacked my way
with
through it.
the async call. So how does it keep track of the numbers then? If you're calling this async and it's just like kind of throwing out there and going, where are you
Well,
keeping
because I'm
track?
passing in my count to each time I call the function. I'm passing in my current count.
And then how does it get it back?
It doesn't need to.
So can you scroll up really quick? What happens to this thing count thing? So you totally.
So I'm still keeping my best path risk.
Oh, okay, so then you're storing it in this best path risk.
So I have my best path risk. So essentially at the end, if I print my best path risk, it's going to be an array of the total risk to get to every spot.
And best path risk is it's an external data structure.
Yeah.
Okay. Interesting.
So that's that. I'm glad this one's finished.
All right.
If this did not work, then my next step My next step was going to be watching YouTube videos about A star. That was seriously my next step. And this was at like 1 a.m. I was at home like sleepy as shit. So I just wanted to get it to work. I'm like, I need an answer so I can sleep. I don't want to have to wake up tomorrow and search about A star. I just want to sleep. So
I feel you, man. You are like,
What
you're
was
like
that?
to the problem. You are like to the problem. Hey, give me the answer. I need to sleep.
No, maximum call stack exceeded. Get out of here.
Yeah.
I'll shut you down. I don't care if you take 10 minutes. I'm gonna go brush my teeth, and if there's no answer when I come back, I'm going to bed.
That's right.
And there was an answer.
Nice. Yeah. Sometimes you just get a bigger hammer, man.
This one was a battle, man.
You got it. You got it. That's cool. All right. So mine. Let's see, mine for 5B. Now, there's another story for 15B.
Can you
mine.
make it a little bit bigger?
No. It's as big as it gets, man. Just kidding. First,
That's good. Thank you.
I can move this window, interestingly, so I can close the search bar. So on mine, interestingly enough, I was like, oh, I'll do this, when I was thinking about doing this as a Dijkstra. I remember looking up, well, when I first saw this, I was like, maybe I should use a caching mechanism for my original thing. I was like, caching mechanism might be pretty neat. And so I ended up looking through caching mechanisms on Rust, and one of them is called the binary heap. It's the heap is a pretty common cache thing, especially when you start using pathfinding algorithms. They all, actually not all, but both A star and Dijkstra's want to use a priority heap. And the easiest way to get a priority heap is to use a binary tree, and the binary tree in Rust is called a binary heap. And so, there's two links. You click on one of them and you're like, oh, binary heap. Oh, well, look at that. They give me the Dijkstra's algorithm.
I can't see it. We only see you.
Oh, okay. Sorry. How do I get that back out? Here we go. So I'll do a new share. Oh, it's interesting that it doesn't give the rest of them. Oops, is it this one? I'll just do the screen for now. So I was doing a binary heap in Rust to see how the binary heap is done. There's two examples. I clicked on one of them and it takes me right to the standard collection. And the example that they give for the binary heap is Dijkstra's algorithm. So I was like, oh, that's convenient.
So where should I change my variable?
See, yeah.
Plug and play.
Yeah, pretty much. So that's
Copy, paste.
that's exactly what I did. So I did the same thing I did with A star. I copied out the algorithm and just changed in the things that I wanted to change.
Well, this is even easier though, because it's Rust code and not just pseudocode.
Exactly. Exactly. Again, the node is one-dimensional. They don't use coordinate systems, so I did have to update it for the coordinates, but it was minimal. And so, so for 15B, again.
I'm confused. How do you do a pathfinding with a one-dimensional thing?
I think it's a good question. I think
Wouldn't it kind of like, how do you have options besides left to right?
Yeah.
I don't know.
there was an explanation as, because when they made the original algorithm, it was supposed to be like a generalized algorithm. I think you're supposed to actually go in and determine whether it's a two-dimensional or three-dimensional path that you're trying to go in, and they just put it in as a node. Because also, oh, the other thing is that these are graphs. It was originally created for graphs.
Okay.
And for graphs, you have a node, and the node, you can go from, place to place. You don't really have, the node is identified by the value of the node. It's not identified by the placement, because there is no coordinate system.
Location doesn't matter.
Location doesn't matter. It's just what node is the current node, and then you look at what its neighbors are, what its edges are, right? Whereas we're trying to put it onto a coordinate system and then put it on. So
Okay.
that was the update. And so I noted it here that the only thing I updated were the fact that we're doing X and Y's because we're doing coordinates instead of node names. Other than that, yep, so I updated that. I think that was it. Nothing else. I'll update the hash map too to make sure the keys are right, and the starting and the goals are also updated. Also, yeah, that's right. So there's a little bit I need to change. But other than that, I added the came from the A star, so that I can redraw my path. But the Dijkstra's does do a cost where it returns the cost as well. The original one that they had only returns the cost. And so I had to add in, I guess, only returns the cost. And so I had to add in the path as well, because I wanted to reconstruct the path. And so I just borrowed that from the A star, but the reconstruction of the path, and making sure that when I write into the priority queue, or that I also write in well, not the priority queue. When I write into the came from, I also include the original nodes as well as the regular nodes. But that was just for my display. So I added these two lines so that I can do my reconstruction. Other than that, okay, so I was taking from 15A, whatever. Other than that, the only thing that's really interesting is what I call the tapestry. Right? And so instead of what I had before, now I have a vector of 132s. And what that essentially creates for me, now that I have it running on here, I can actually run this thing for you guys. And we'll probably run this on a demo so that you don't get like just incomprehensible display of numbers. You guys can see this, right?
Yes.
So 15B on this one. And so the first time I run this, it just displays a grid of the, well, it's actually running the pathfinding, but yeah, there's my answer. But did I save this?
Looks like it.
Oh, why didn't it?
This is the Github.
Oh, yeah, absolutely right.
Just copy and pasted it.
Yeah.
Man, the GitHub one looks just like VS Code. It's hard
Right,
to tell the
yeah,
difference.
It's really well made, actually.
Yeah.
It is VS Code.
Even-
It's the same engine.
Yeah,
All right, so let's try this again.
Same also.
that's cool.
GitLab also. Same
Yeah.
these days. Implemented recently.
So running that. So this is what first ends up. So you see like
Your
each
tapestry.
yeah, it's my tapestry. So this is for me to visually be able to confirm that my algorithm was doing what it's supposed to be
I
doing.
see just the top corner. I see 1, 1, 2, 2, 3, 3, 4, 4, 5, 5.
Right?
And then yeah, down at the bottom, if you look at the bottom right, that 1, 1 changes, goes all the way to 9, 9.
Yeah.
Cool.
That's neat.
Yeah.
Easier is
Yeah, I like your printing of it. Looks really
I
clean.
compared it just by comparing like few digits, not all.
Yeah. And then after we do that, then I gotta flatten that out, right? Because that's gotta be one large thing. And so first, then everything gets flattened out, all the spaces are removed. So instead of a vector of numbers, now it's just a vector of numbers.
Giant,
A vector of
yeah.
numbers, right? So it's all smashed together now. After it gets all smashed together, then I do what I did before, as I prepped exactly like I did before. I prepped each one of these for the pathfinding with this time Dijkstra's. But I need to prep it with the point and the value of the point and the list of neighbors. Since yeah, Dijkstra's works on graphs mostly, so it already has its edges. But we have to tell it what its edges are. So that's what I do here. Feed into Dijkstra's, get my answer.
Cool.
So I got lucky. I got the Dijkstra's for free. And I got the A star for free. Well, kind of.
You gotta do
free-ish.
some work on it.
That's really, I should start working. I didn't try to solve yet.
I got to the same A* wiki page and I saw the pseudocode, but I'm like, I can't fully understand this. I can't
I
translate
think-
this to JavaScript because I don't know enough yet.
It takes knowledge too to be able to copy and customize it to your needs, right? because I also tried to do from Wikipedia, but no, I couldn't.
And so like I told, we had this conversation before, and for, you know, for entertainment purposes, I would recommend you guys, for those of you guys who are out there and wondering, where can I pick up some more interesting algorithms? And so one guy that I typically recommend, just because of it, you know, if anything, entertainment value. This guy. Yeah, used to be called Coding Rainbow, but then, you know, with, you know, brand issues.
It's not even
and
that simple. It's just got one thing. Can I not do anything with Rainbow then?
Well, educate in the education space, maybe not.
Oh, actually, I do know this stuff.
Yeah,
Coding challenge.
He does only live, no? He does only live coding, no?
yeah, he does live coding.
Yeah,
Yeah,
Okay.
I think I watched some live coding.
but he's got a lot of great videos. And you know, because everything is visual when he does it, it's a great way to
Yeah.
process a lot of the things that are going on behind the scenes.
And he's an instructor, so he's more like
And
teaching
he's-
you about.
He's an
life.
actually accredited college professor who's been doing this for many years. So yeah, so he knows what he's doing. But he does, he did a couple for pathfinding, I remember. And, you know, like I said, just for the fun of it, while I was doing A-star, I had him going, you know, running in the background because I thought, hey, I
Yeah,
remember this
second
guy.
one, A-star.
Yeah. And so he does it fast. He does it in JavaScript because he's using P5.
I should watch this.
But just, you know, there's a couple, you know, great things, takeaways of this. You get to watch someone else who's, you know, what I would consider a fairly decent programmer. I wouldn't say he's like the best because he's obviously not a corporate programmer. He's an educational programmer. So, you know,
Welcome.
but he does a great job explaining the algorithms and visualizing them so you can kind of see what's happening as he like builds it together. And he iteratively shows you as he's building the algorithms what's happening and why certain pieces of the algorithm changes what it changes.
In the last video, if I remember correctly, because
Is that me?
I think Farouk's watching it.
Okay.
That was me. Sorry, guys.
That's Farouk.
But yeah, the last thing, it's been a while since I've seen it. The last thing I've been watching was machine language, genetic algorithms, stuff like that. And again, really great resource to at least get your foot wet.
Yeah.
It's a great job.
Cool.
But anyway, yeah.
So
So
if I watch all of his videos, then I can get like an honorary CS degree, right?
somewhere in New York, possibly, yeah. But
Put it on my resume.
Just try.
I watched our coding chain videos.
so there you go. So yeah, so that was day 15 for me. It was a little bit more straightforward.
Cool.
All right. So
next time.
3 hours later,
Are we doing
maybe and then some.
16 and 17 next time then?
Yeah. So let's get the next two for.
Oh, F. 16 was that packet decoder. That wasn't fun.
But,
17. Trick shot didn't take me that long. That one wasn't as bad, I think.
Yeah.
That one was quick compared to 16 for me.
Well, let's end this here, and then we'll plan to cover the next two on Wednesday. All right. So thanks for suffering through us, through this with us, and see you in the next one.
Take care. Bye-bye.
Bye, everyone.